Morning, Gareth.
Yes, good morning, Manny.
So, yeah. So today we will be starting with little more interesting topic. We'll take up domain 3 first, and then we will do domain 2 because that is a little more interesting. And can you see the domain, the slides?
Yes.
So any question from yesterday's session? Any doubts?
No.
Okay. So let's dive into straight away to domain 3. So it is security, architecture, and engineering, and it has a weightage of 10%, right? So the first concept in domain 3 is security design principles. Now we know that we've understood the governance, and we will definitely be discussing today the asset security part. We know about how in an organization uh, a security governance is to be implemented. It is to be monitored. It is to be strengthened by various tools that we are having. But now coming, let's come down to at a step down. We started from the top. Now we are going a step down and understanding some technical concepts, some hands-on concepts also, so as to ensure that the security is totally integrated into our system. So security by design principle says that the first term is secure defaults. This has been taken from NIST SP 800-160 publication. The default configuration reflects a restrictive and conservative enforcement of security policy. Now, uh, so what do you understand by this term, secure defaults? In the layman term, let's take an example. What will be a secure default?
Secure defaults, it's if the system fails, it should stop people from entering. Let's say we're using a firewall, and if the firewall fails, it shouldn't be accepting any incoming connections into the system. So if it fails, it should close. It shouldn't be allowing anything.
Absolutely. So secure default means configuring a system, an application or device so that it is secure out of the box without requiring the user to tweak the settings. It is a security by design principle, right? By design, whatever you have designed, the default settings should be enough to ensure security. If we further break the two letters, secure and default, your default settings in any system or a network should be secure enough to ensure the safety and security of the resources or the assets. So it is a security by design principle. Insist on shipping products with open ports, default admin passwords, or unnecessary services. The vendor sets them up in the most restrictive and secure way by default. So if you want to pick up a firewall, as you said, the secure defaults would be that it should not be allowing any port in the first place itself. So you are forced to configure it for your configuration. So your default settings are not a giveaway. For example, nowadays, if you pick up any IP camera, the IP cameras are getting hacked left, right, and center. It is so easy to hack an IP cam. Firstly, because it's an IoT device, it does not have those stringent security uh, when it is manufactured. So it is a hacker's delight to access any other IP cam and hack into it, because the defaults are not secure. It is a plug and play device. It is designed for, you just switch it on and it should by default take the network settings and it should start working, right? So that is not a way a particular vendor should be putting the systems into the market. It should be at the default, secure default settings. That is what the SP 800-160 says. So that the person who is taking it is forced to configure it in as per the settings, and it is not running on unsecure default settings. Characteristics of secure defaults are least privilege by default. So minimum privileges should be assigned. Minimal attack surface. So your ports and other protocols should be disabled. Only the necessary ones should be enabled. Safe configuration choices. Strong encryption on it should be on by default. For example, HTTPS instead of HTTP. Strong password policy is enabled. No default admin credentials are enabled. Very important. So most of the security IP cameras, they have if you want to enter, you don't have to do any brute force. Just put admin, and more than 50% of them will be cracked, because the owners have just bought them, and they have just not bothered to change the password. They have just put it admin or password. Those will be the credentials, and your IP camera is running. So if you get into that camera and you just put this default credentials, you will be able to access that camera. So this should not be the standard practice. And yes, it should fail securely. So what is fail secure is our next term, indicates that the component should fail in the state that denies rather than grants access. So you rightly said that if you have maybe a firewall and it malfunctions, then it should stop all traffic rather than opening for all the traffic. So the by default design, when a component fails, should be failing securely, right? And that is extremely important for secure design principles. And very important, you can trust but verify. Depending upon the initial authentication process to gain access to the internal secure environment, then relied on generic access control methods. So you can trust them. The authentication can happen, but definitely verification is required. Due to changes in threat landscape, this particular secure design principle, that is trust but verify, is no longer considered sufficient. We are normally into a multi-factor authentication scenario where every time, even the trusted device which has was earlier on the network, we are still doing the complete authentication process, and the trust but verify thing is no longer considered sufficient. But that's what was earlier acceptable norm, which is given in SP 800-160. So now what now normally what do we follow is zero trust security. We really don't want to trust even the some things which are internal. We definitely don't want to trust what is from the external. So there is something what we normally use follow is zero trust security. In this, addresses are The limit addresses the limitations of the legacy network perimeter based on security model. Treats user identity as the control panel, assumes compromise or breach in verifying every request. It already assumes that this particular request could be a breach or a compromise, so we will not trust it. So there is certain things which needs to be done is to verify the identity, that is access control, stringent access control, manage devices, manage apps, and protect data. So in this zero trust security, we would it's a model that assumes that no user device or network is inherently trusted, even if they are inside the organization's perimeter. The core idea is never trust, always verify. The goal is to limit access strictly to what is necessary and continuously validate identity and device health. So certain principles are as written is verify explicitly, least privilege access, assume breach. Key technologies which are used to implement zero trust security is multi-factor authentication, network segmentation or micro segmentation, continuous authentication and monitoring, device posture checks, and identity and access management implementation. So these are few of the technologies which nowadays we will have to implement to ensure the zero trust security. And we definitely want to have in any organization, the privacy should be by design. It should not be afterthought. It should not happen that a particular application or a project is at the completion stage, and that is the time when the privacy is being thought about. It should be at the initial stage itself, when a particular project has the brainstorming about a particular project is happening. That time itself, the privacy should be the one of the key pillars when a particular major application is getting built, or a major change to infrastructure or a network is happening. Making privacy an integral part of every system, technology, policy, and design process. It has 7 steps or 7 principles: proactive and not reactive approach. So the mindset of the organization should be proactive towards security and not reactive. Not when things go wrong, then you say, "Oh my God, what should we do now?" Privacy should be as the privacy should be as a default setting. Privacy must be enabled in the design. Privacy should be a positive sum approach and not a zero sum approach. End to end full life cycle data protection should be ensured. Visibility and transparency should be ensured. Keep privacy user centric. Applying this principle in implementing a layered defense as part of zero trust strategy ensures privacy. So there are two terms here which are very important for you to understand. That is layered defense. What is layered defense?
Defense in depth.
Yeah, yeah. Why do we use? Where do we use defense in depth?
Say that again.
Pardon?
As I said, I thought you were asking me a question.
Yeah, yeah. I'm asking. Can you explain defense in depth? Where are we going to use it?
Oh, okay. Yeah, defense in depth is when you have layers or of defense that you have put in an application, like if you are going to the office or if you're going somewhere, you have a security or physically somebody is there to inspect your ID, check that you have access to enter the building, and then before you enter into the room, you have a privilege, you've been assigned access, and then before you even open the computer or turn the computer on, you have access. So all these steps, every stage or every step of the way, you have security implemented, and that is what called the defense index or security layer.
Yeah. So let's very nice. I mean, that is how it is. So if we discuss more fundamentally, is that yesterday we discussed an example about securing your asset like gold, which is a very high value asset. We are securing a not so high value asset like a iron bar. So when you are talking of a gold bar, you have a very high value asset. So instead of just putting one control, right, and that control fails, then that is a single point of failure. If that becomes the key issue, then it would be advisable to put more controls, so that if that particular control fails, still protection is guaranteed. So, but what is the disadvantage of defense in depth is that you are putting more controls, so means more resources needs to be allocated for that particular asset protection. So eventually, it has to be aligned to our business needs. That are we, is it profitable for us, or is it required for our business to allocate so much resource to protect a particular asset? For instance, for a gold bar, you definitely will use multiple controls so as to protect that asset, but and that will be a layered defense, which the aim would be that even if one particular control fails, the other control still delivers and there is asset protection guaranteed. On the other hand, when the value of the asset, when the criticality and sensitivity of that particular asset is not so great, that is in case of iron bar, we need not allocate, we need not choose the defense in depth scenario, right? So defense in depth is a layered security strategy where multiple different security controls are placed throughout an IT system to protect an high value asset. The idea is if one control fails or is bypassed, other control still protects the system. This multiple door, locks, guards, and alarms in the secure building. It's like, for example, and the core principle are multiple layers, diversity of control, redundancy, coverage across attack vectors. Examples would be in case of a physical security, you would put a guard, you will put lock, you will put CCTV, and you will also put man traps, right? So you will put this multiple controls so that even if one control does not deliver, the others will. In the technical controls, you will put firewall, you will also put IDS, IPS in the network, you will put an antivirus at the endpoint, and you will use encryption. So all of this is layered defense strategy to complement each other for your high value data. Administrative controls would have policies, training, background checks, all of them together. Network would be for the network specific defense in depth, you can have segmentations, VPN, access control list. For the endpoint, you can have patch management, you can have antivirus installed, you can have EDR, endpoint detection, disk encryption. For an application, you can have secure coding, web application firewalls. For data, you can use backup, DLP, rights management. So these are multiple controls which you can use in series, sorry, you guys can use in parallel so that all of the ones deliver, and if even if one is breached, the other will definitely protect the system. So here is what zero trust will by implementing layered defense as a part of zero trust strategy, you ensure privacy. So these are the 7 principles you must know. No need to memorize them, but it is good to know them.
Okay, I got a question here.
Yeah.
If you can go back, yes. So on the heading, you said making privacy an integral part of every system, technology, privacy, and design process. And my
Yeah.
question is, So does that mean that when you are designing a system, the privacy part should be part of the information gathering stage of the system? Or because I'm seeing you said embedded in the design, or is it at the in design phase?
Okay. Yeah. So when we say that initially, if we talk of SDLC, for instance, the first phase is initiation and planning phase,
Mhm.
right? And the second phase is system design phase, or the main phase, where you will be discussing at the first point, about the design of the system. So
Right.
that, so when you are in the planning phase, initiation and planning phase, you have to identify the security requirements at that step itself, in the initial phase itself. When you are in the initiation and planning phase, at that step itself, you should identify your security requirements.
Okay. Okay.
Design or decide on the layered security approach as part of architecture goals. So in the first step of the SDLC itself, you are so it is an integral part, embedded part, because at the first phase itself you have started talking about security and privacy. During the system design phase, which is the main phase of defense in depth, at that system design phase, you would probably be talking about what type of controls you are going to choose, right? For example,
Okay.
network segmentation, role-based access control, encryption, at rest and in transit, physical security control, administrative policy. So here you will be talking of little specifics. In phase 3, which is the implementation or deployment phase, you will deploy the layers chosen in the design and ensure diversity in the controls. And in the next phase is testing and verification phase. Testing each layer individually and together by PT, red teaming exercises, right? VAPT. So that is where you are verifying that whatever controls you decided, you have designed and implemented, they are delivering. And the last phase is the maintenance phase, where you are doing patch management, you are adjusting your layers, you are adjusting your controls based on the requirements as the requirement arises. So it is to be applied really early. Security added late is expensive and less effective. If you apply it later, it will be expensive and it will be less effective. Early defense in depth planning ensures no single point of failure in the system. It aligns with the security by design and privacy by design principles. So these 7 principles aligns with the fact that at the very first phase itself, you have to consider this. So security by design means keep it simple, right? It is not nothing complicated. It is it will be a very basic requirements which we can pick up of existing framework and evaluate it for our requirements and see whether this framework is delivering, and just do it in that fashion, and that is it. It is nothing complicated. Com- Complex is the worst enemy of security. Build best in suit over best in breed solutions are one approach used to simplify defense in them. Simplicity also helps you avoid configuration mistakes, enables organization to move forward, improve incrementally rather than demanding perfection. Right? So keep it simple principle definitely works in secure design principles. So, yeah. So these are certain conceptual things when we are talking about security, zero trust, and secure design principles. Now we will be moving about and understanding a little bit about cloud models and the services which are existing in our cloud models. So we know three types of cloud architecture is there. We have a public cloud, private cloud, and hybrid. What is public, private, and hybrid?
Public um, cloud, it's example is like AWS or Azure. They provide service based on a shared. They have shared tenants. They are providing the infrastructure and even sometimes the application and the software for you, and you are sharing with other people. It's not like you are sharing the application, but you are sharing the infrastructure with other people because they have provisioned it for others to also use it. And then the hybrid, it's a mixture of the public and private. The private is when you as an organization you develop it for yourself and then to host all your applications. So the hybrid is having the some features of the public and some features of the private.
Absolutely. So this is how the basic definition, and it's absolutely brought out correctly. In the public cloud services is often over internet, shared across multiple customers or multi-tenanted. Ownership is that managed by a third-party provider like AWS, Microsoft Azure, or Google Cloud Services. Access, anybody can access and use it, usually via pay-as-you-go model, mostly preferred. The advantages is it is low upfront cost, scalability on demand, provider manages infrastructure, right? The disadvantages of a public cloud is it is a less, but there is less control over infrastructure. Data security and compliance concerns are existing in the shared environment. For example, Gmail, Dropbox, AWS EC2. So few of this shared environment have certain concerns as far as the security goes. Then the more secure one is the private cloud, where the cloud environment is dedicated to a single organization only. Ownership can be on premise or hosted by a third party, but used exclusively by one organization. So there is no multi-tenanted structure over here. Single organization is using it. Access is restricted to the organization internal use. The advantages are more control over security, compliance, and customization, better for sensitive workloads, and disadvantages is a higher cost, requires in-house expertise for self-management, and examples are VMware-based internal data center or OpenStack private cloud. And the third one is a hybrid cloud. A hybrid cloud combines the public and private cloud environments, allowing data and applications to move between them. The ownership is managed by a mix of organization and third-party providers. Access is flexible, workloads can be distributed based on needs. Advantages balance between scalability, which is public, and control, which is private. There is a cost optimization, there is a disaster recovery and backup flexibility in this. The disadvantages is that yes, obviously this is complex to manage and integrate, and security challenges in data transfer between the two clouds or the two segments of the hybrid cloud definitely exist. So example is storing sensitive customer data in private cloud, but running analytics in a public cloud. So many companies keep their sensitive information on premise in a public cloud, and rest of the business can run on the private clouds. Similarly, let's differentiate between IaaS, PaaS, and SaaS. Yeah, infrastructure as service, platform as the service, and software as a service. What do you understand between the three terms?
Software as a service, um, the cloud provider is providing everything. All that you have is just probably your data. And then platform as a service, you are providing the the application that you are running and your data. The cloud service provider is providing the OS and then the hardware, everything. And then IaaS, you are responsible for the OS, the application, and then the data.
Okay. Yeah. So this definitely needs a little more. Yeah, the basic fundamental understanding is absolutely correct. So let's dive into the shared responsibility model. So basically, this infrastructure as a service, platform as a service, and software as a service would be based on a shared responsibility model. How much is the responsibility of the cloud service provider, and how much is the responsibility of the customer? So here we have the dark blue highlights the customer responsibility, and the grayish shade uh, displays the cloud service provider responsibility. When we are on-premise setup, everything is the responsibility of the customer, starting from networking to storage of data to maintaining, installing and maintaining of servers to virtualization to operating system to middleware to runtime to data to applications. Right? Everything is your responsibility. When we talk of infrastructure as a service, then up till virtualization is taken care by CISSP. Okay, up till this part. Rest all is the customer's responsibility. When we talk of the platform as a service, when the platform is being provided by CSP, up till runtime is his responsibility. The data and applications are still being maintained by the customer. And in case of a software as a service, entire responsibility is the cloud service provider's responsibility. For example, in case of a software as a service, we use Gmail, we use Microsoft 365, we use Dropbox, we use Salesforce application. So they are end user application available on demand. So entire setup, the entire app steps are being maintained by the cloud service provider in that case, and the user or the customer is straight away you're just using the raw services. In case of a platform as a service scenario, the example would be Google App Engine, Microsoft Azure App Services. So here the deployment of the web application without managing OS patches and server setups. So application level updates would be responsibility of the customer. Managing the data which the applications are using will be the responsibility of the customer. However, maintaining the OS, updating, upgrading, patching, patch management, change management, all that at the OS level, at the middleware level, would definitely be the responsibility of the CSP. He provides a platform for this particular service provides a platform for developing, running, and managing applications without worrying about the underlying infrastructure. So this is the key features of this particular cloud implementation methodology. When we talk of infrastructure as service, you provide the basic computing resources. The basic computing resources are provided by the cloud service provider, like server, storage, networking, virtualization. What the customer is supposed to manage is operating system, applications, data. All of that is the responsibility of the customer to manage. For example, provider manages physical hardware, virtualization, basic networking. Advantages is the most control. Advantage that the customer has the most control as well as the flexibility, and you pay only for what you use. For example, is AWS EC2, Microsoft Azure Virtual Machines, Google Cloud Computing, Google Compute Engine. So, a few of the examples of infrastructure as a service. So,
Okay,
yeah,
Manny, I got a question here. If you go back to your previous slide, yes, so under the SaaS, I
yeah,
see you have it written as the CSP responsibility.
yeah,
But if I allow I'm an organization and let's say I'm using email service like um, Microsoft email, and then my staff have to be accessing it. Am I not responsible for the data that I'm allowing people to have access to the email service?
yeah. So, absolutely. Now, that is your concern when you, if your concern is that you are using a SaaS platform. So, for example, Gmail, right? All of
Yeah.
us use only. So now, in this SaaS platform, the data, what I have is a very minimal data, which is resident on my device. Rest everything is in the cloud, for which I don't have any control. Okay. Now, yes, by reputation, we can say that Google is a really very trustworthy and safe platform, so breaches are very limited. But if we go by zero trust, we cannot trust anybody in these days, right? Even if it is a big name like Google. So if I have a very critical application for which the data transfer has to happen, and I am supposed to be using a Gmail as a source of data transfer, then I definitely have that concern in my mind. So what should I do? I should implement some additional control. If I'm using the SaaS service and I want, my concern is that there is a likelihood of the breach, then I may use an additional control like encrypting the data and then mailing it, right? So Google does not have that particular keys, or those keys. So only I have, and the sender and the recipient is having. So whatever gets transferred on that mail is encrypted, and when it comes to me, I use my algorithm and decrypt it. So that is why I use that medium. However, I keep it more secure. So I have put additional control to protect my data, right? Was that your? Have I answered your question, or is there any more means?
Yeah, I think it's okay.
Yeah. Now, one more important thing is that when you're going for something like a SaaS, which end to end is managed by the CSP. Now, the problem with CSP is what? Suppose there is a server farm, right? There are, say, some millions of terabytes of space which is available in a server farm, and that is for hiring. Those cloud service providers say anybody who wants can take those services. Now, there would be few businesses which will be running in that particular server farm, so they will be using that particular hardware, those servers on which they will be hosting their applications, their everything. Now, the moment they move away, the same infrastructure is offered to. So it's a multi-tenanted environment, right? So in that scenario, when if you have put your critical data, something very critical, and now you are moving out of that particular cloud service provider, there is a possibility that your data can get compromised, right? So that is why having additional control is always recommended whenever we are going for a software as a service. We definitely need to encrypt our critical data, and generally put more additional controls, probably keep it on premise rather than keeping it stored in the cloud. So moving further ahead deeper into the IaaS, it is the cloud service providers building blocks like networking, storage, and compute. The CSP manages staff, hardware, and data center. Here are the examples of infrastructure as service. For a platform as a service, the customer is responsible for deployment and management of apps, and CSP manages provisioning, configuration, hardware, and OS. For a platform as a service, uh, the application and data is managed by the customer. Rest everything is managed by the cloud service provider. So here's a question for you: is the platform as a service means that it is serverless, or what is the difference between platform as a service and a serverless? How different they are?
Platform as a service, it's not a serverless. Um, for a serverless, serverless is kind of similar to SaaS. You have an application that kind of runs when an event, you have configured it that when certain event or an action occurs, then it fires or it runs for you. And in that case, you don't manage anything. Everything is being managed by um, cloud CSP. That is my understanding.
Okay. A platform as a service, you deploy applications into the managed platform where the provider handles the infrastructure like OS, middleware, and runtime. You still think about serverless in terms of scaling and uptime, right? And you often deploy your apps to a preconditioned runtime environment. So this is the key difference. In case of a serverless, sorry, in case of a serverless, you run code in response to events without managing servers or runtime environments. The provider spins up the resources only when needed. You how it works? You write a small event-driven function. No server provisioning or scaling configuration happens, and the platform does it automatically. The code starts. The cold start may happen if function doesn't hasn't been used for a while, right? So the billing cycle, in the billing cycle, you're charged only for execution time and resource consumed when your function runs. For example, AWS Lambda or Azure functions or Google functions, when the function runs, that is the only time you will be charged. So you have less control over deployment environment. You application scales automatically. Application code only executes when invoked, and you are charged only then. On the other hand, on the platform as a service, you have more control over the deployment environment. Applications has to be configured to auto scale, and applications takes a while to spin up. It will not automatically start. It will take a while to spin up. What is common is they have write codes and no server management. Both don't require you to manage the server, so that's the common thing about both. But there is a fundamental difference between two, in the way they will be functioning, as well as in the way you will be charged for using the services. So coming to the last of the cloud models is SaaS, in which everything is the responsibility of CSP for management, operations, and service availability. The customer just is using the on features which are available. Salesforce 365, they are few of the examples. So we know the difference between public, private, and hybrid. So and everything runs on your cloud provider's hardware. That is in case of public cloud. Advantages include scalability, agility, play as you go, no maintenance, and low scale. On the other hand, on the private cloud, the cloud environment is in your own data center. Advantages include legacy support. For sometimes you want to use the legacy systems, so it is better that you use it in your private cloud because it is more protected, and access to hackers will be limited because it is not open to public. Control, you want more control and compliance, then also the private cloud model is recommended. The hybrid combines public-private cloud, allowing you to run and run your apps in the right location. Advantages include flexibility in legacy, compliance, and scalability scenarios. So yesterday again you asked something about CASB. Now this has come up as a definition. So when you are using multiple cloud environments, so one company may not be using only one service. You may be using multiple services from multiple cloud service providers to ensure that access control to so many different providers is managed in the most correct way. You approach a access control broker, cloud access control broker. He is a gentleman who will give you a solution how the access can be controlled and optimized so that you don't have a security issues coming up whilst you are using multiple services of different cloud service providers, right? So cloud access security broker is giving you the access security. Uh, and why he's a broker? Because he is negotiating with multiple providers, not the single vendor. He's brokering with multiple vendors whose services as an organization you have taken, and which is definitely a cloud services. So he's a cloud access security broker, CASB, and he ensures that across the multiple platforms your policy requirements are enforced, right? You have a standard set of your policy enforcement requirement, and there are multiple vendors, and the CASB is ensuring that this security policy is enforced across those multiple vendors, the cloud service providers. So that is the advantage of taking a CASB into thing. Otherwise, there are chances of mismanagement, and shadow IT can come into play where things can be unregulated. There could be some servers which are not getting regulated, in which policy of your company is not getting enforced, and that can lead to breach. Right? That is what exactly the CASB means. So now we will be moving on to cryptography once we have finished with the cloud and its key terms, the cloud models. Uh, this is going to be a little interesting. So yeah, we will be moving on to the cryptography part. So what do you understand by cryptography, and why do we need cryptography?
So cryptography is a process of converting a plain text into a cipher text so that um, unauthorized users cannot read the message. You just hide the meaning from, you just hide the message from unauthorized users. Um, so it's only the authorized user who will have the right key to decrypt it, to change it from the ciphertext to plain text again. And we do it just to prevent confidentiality, integrity.
Mhm. How is encryption going to help you in integrity?
Yeah, encryption will help me in integrity because I just want to know if somebody hasn't been in the middle of a conversation and then altering what might have been transpired. Because if, like, I'm sending you a message, and if somebody is in the middle of our conversation without the two of us knowing, that person might be able to alter the message and that I sent to you, that with the intention that you have received it, that person received it, change the message, and then send it to you. You send it back, that person received it, change it again, and then send it to me. So that is where the encryption plays a part here, and it is with hashing those. That's when it prevents integrity.
Yeah. So yeah, fundamentally you are right, but mostly when we what we fundamentally understand by encryption or basically cryptography we are using to have encryption, like we want to use a particular cryptographic algorithm to modify the message and convert it into a cryptic text. Cryptic means something which cannot be read, right? Which cannot be understood. So plain text and cipher text. So a plain text is something which I suppose we two of us wants to communicate something very secret. Then my plain text, and I'm afraid that it will get compromised. So that plain text needs to be converted into cipher text. For that, the process of converting it using a particular model or algorithm, that is where we are using cryptography for. So cryptography is a science and a practice of securing information by transforming it into a form that is unreadable to unauthorized parties. So here primarily we are targeting confidentiality aspect, whilst we may be using it in bits and pieces for integrity, but primarily the this part is taking care of the confidentiality requirement, that is the cryptography. While allowing the authorized parties to read and process it, it uses mathematical algorithms. It uses mathematical algorithms and the keys to ensure confidentiality, keeping data secret from unauthorized access. Yes, it definitely aids in integrity also, as you rightly said, because if it is a eventually it is a message which is not understood, so it ensures data isn't altered undetectably, so the person will not be able to understand it, so it will not be able to alter it also. So in a way it aids in integrity. it it helps in authentication by verifying the identity of the parties, and it also helps in non-repudiation by preventing denial of actions or messages sent. So in short, cryptography turns readable messages, which is a plain text, into a unreadable data, which is a ciphertext, and vice versa, using algorithms and keys, which we'll be discussing in detail, to protect it during storage as well as during transmission. And in the today's world, as we will be going ahead, we know there are two types of cryptographic symmetric and asymmetric type of cryptography we are using. And with the use of quantum post quantum cryptography, both of them are at you know it's been very difficult to protect our encrypted messages, because quantum computers are able to break it easily. So as and when the quantum computing is going to gain its development efforts and more freely available to hackers, the our symmetric and asymmetric cryptography is under a tremendous threat. They can easily be able to break the keys. So that is what is the new challenge in today's world we are facing towards our secure symmetric and asymmetric cryptography. However, uh, when we talk of quantum computers breaking our keys, a symmetric system is still better than asymmetric one. The quantum processors are more immediate threats in asymmetric cryptography, whereas symmetric ones are still a little harder to break. So, what is a symmetric crypto system?
So with a symmetric crypto system, you use a pre-shared key. So the same key that is used to encrypt plain text is also used to decrypt the plain text.
Yeah. So, same key is you getting used. But the biggest problem with symmetric system is what?
The biggest problem,
The biggest problem from security perspective is the sharing of the key, because suppose we have decided a key, both of us, and we have an algorithm and we are using that key to encrypt our data, and now I at some point of time would be changing it, right? Because I can't keep it the same key for indefinitely. So we would have decided on a policy that okay, every 4 hours we will change our key. Now, and obviously on the networks it is much faster, we know that. But suppose if we keep a 4 hours time frame also, how do we share a common key every 4 hours securely, is a challenge for us. Because if we are so far away, and every 4 hours I have to change the key. If I send it on email, then again, we were already discussing that how email can be easily compromised. So that is a problem. The key sharing becomes, from the security perspective, a very big challenge, right? And how safe is crypto system when we talk of quantum computing? That for a 256-bit key of in the symmetric system, a quantum computer has for a quantum thing, a 128-bit key will have the same strength as a conventional computer. So quantum computer will of 128-bit key in a quantum computer will have a same strength as a 256-bit key in a conventional computer. And doubling the key length from 128 to 256 does not make the key twice as strong. It makes it 2 raised to power 128 times more strong. Right? It's 2 to the power n. So that is how strong the things become. Whereas in the case of a asymmetric ones, where we are using different set of keys for encryption and decryption, wherein I have a public key and a private key pair. So we say it a key pair, and the examples are RSA, elliptical curve, and lattice based. RSA and elliptical curve. These are some of the examples. So they are the ones. Doubling the key length increases the difficulty to break by the factor of 8. It's not a sustainable advantage. So even if you are increasing the length of the key, it is not a very sustainable advantage in the symmetric key encryption. So the lattice based is, when we are talking from the security perspective, the lattice based is the most secure system, in which the three-dimensional array of regularly spaced points are used to finally come at the key pair. What will be your encryption key? We use a lattice system, and that is in the quantum computing environment. This is considered to be the most safe uh, technology rather than symmetric and asymmetric. So this is a very important point for you to remember in exam, that whenever you see a question and it says that which is quantum resistant technology in terms of cryptography, you should be choosing the lattice system above the symmetric and asymmetric. So let's understand cryptography from this base. So what is a code in cryptography? A cryptographic systems of symbols that operate on words or phrases and are sometimes secret but not always, but don't always provide confidentiality. So a code is something which is again a cryptographic system or symbol that operate on words and phrases and are sometimes secret also, but don't always provide confidentiality. On the other hand, a cipher are always meant to hide the true meaning of the message. So it is always secret. A cipher is always secret. When we talk of ciphers, there are stream ciphers, like as the data is getting streamed, it is getting encrypted by the algorithm in the real time basis, right? Then there is a block ciphers in which a certain block of data is taken, that is encrypted and pushed out. So the encryption is happening in blocks, in chunks. Whereas in stream cipher, it's a symmetric key cipher where the plain text digits are combined with the pseudo random cipher digit streams, the key streams we are using, and in the stream cipher, each plain text digit is encrypted one at a time with the corresponding digit of the key stream to give a digit with a ciphertext stream. So it is streaming, it is happening on the real time basis. In a block cipher is a method of encrypting text to produce a ciphertext in which a cryptographic key and algorithm are applied to a block of data. For example, a 64 contiguous bits. So they will take a block, encrypt and push it. Take a block, encrypt and push it at once as a group rather than to one bit at a time. The other key definitions are substitution. Substitution is the use of encryption algorithm to replace one character or a bit in the plain text message with a different character. You substitute it. The earliest, the few of the earliest ciphers like Julius Caesar used to use the substitution one. It was developed on one of the easiest cipher of this type known as the Caesar cipher. In Caesar cipher, we used to substitute the alphabet from different order. Like if A is becomes B, so we take plus one. So in the cipher text, all the digits will be plus one. So that's how you substitute the original place with the other place by some logic, whereas which will be plus one or a little more complex logic, and that is the easiest cipher called Caesar cipher. Then there are other ways to generate the ciphertext, that is transposition. In transposition, you use an encryption algorithm to rearrange the letter of plain text message, forming a ciphertext message. So you will be jumbling it up in some logic, and that logic you will be again applying to convert the ciphertext to plain text. Initialization vector IV is a random bit string or random break string. It does not have any logic or a value, just a random bit string, also known as nonce. That is XORed function. That means if there are two similar bits, then when you XOR it, it will give 0, and if there are different bits, then it will give 0 and 1. So that is how the random bit string is XORed with a message, reducing predictability and repeatability. Size of the IV varies by algorithm, in but is normally the same length as the block size of the cipher, because the block, if it is a 64-bit block, even if you are doing a XOR function, the output will be a 64-bit only, so the size remains the same or as large as the encryption key. So Caesar, Vengeance and one-time pad, three very similar stream ciphers. They are the three very similar type of stream ciphers. The main difference between these ciphers is the key length. Whereas in the Caesar cipher, which is the oldest kind of a stream cipher, you are using a, uh shift. Your shifting cipher uses a key of a length 1, plus 1 or minus 1 or that, like that. In the other one, you use a longer key, usually a word or a sentence, and in a one-time pad, you use a key that is as long as a message itself. So there are different type of symmetric cipher methodologies which used to be there earlier and which used to hide messages. It when you and cryptography has been there not only with the networks, it has been there widely used by military. Then they used to pass the messages from one place to other, even by a person or even by birds. Even that time also, these type of cryptography were used to be used. So one-time pad success factors: to be successful, for a one-time pad to be successful, the key must be generated randomly without any known pattern, at least as long as the message has been encrypted, and the pad must be protected against physical disclosure. Each pad must be used only one time and then discarded. So all of these conditions, if they are met, then only there is a chances of this particular one-time pad to be successful. And uh, so another concept in cryptography is zero knowledge proof. In zero knowledge proof is a communication concept. A specific type of information is exchanged, but no real data is transferred, as with the digital signatures or digital certificates. More simply, if it enables one to prove knowledge of the fact to another individual without revealing the fact itself. Okay, so this in the zero knowledge proof, example of so a non-technical example is there: a magic door and a secret word. There is a cave with two paths, left and the right path, connected to a locked magic door in the middle, right? If that is a scenario, the the prover knows that the secret word that opens the door, and the verifier stays outside and tells the prover to go down either the left or the right side of the path. If the prover appears on the requested side every time without fail, the verifier becomes convinced that the prover knows the word, but never learns the word in actual. So you don't reveal what is the thing, but the knowledge of that can be proved by following a particular pattern. So that is a concept of zero knowledge proof. So in a technical example, in a typical type of a login system, the client can prove they know the password by performing mathematical operations involving cryptographic challenges from the server. The server verifies the proof without ever seeing or storing the actual password, right? So that is a scenario in case of a technical example of zero knowledge proof, that you are not revealing the particular thing, but you are doing something which eventually shows that you have the knowledge of it. Another concept is a split knowledge proof. In a split knowledge means that the information of the privilege requires to perform an operation in divided among multiple users. This ensures that no single person has sufficient privileges to compromise the security of the environment. In split knowledge proof is a security principle where sensitive information is divided, right? So no person has the full information, and only all when all the parts are combined and reconstructed, then only the effect the data can be understood. For example, a pin and an encryption key at ATM transaction, right? ATM hardware has a part of encryption key, a bank server has the other part, and when both parts are combined during the secure transaction and then only the secure transaction can happen. Otherwise, it will never happen. So there is a split knowledge uh, concept. The other concept in cryptography is the work function or the work factor concept. In work function or work factor is a way to measure the strength of a crypto system by measuring the effort in terms of cost or time to decrypt a message. So, usually the time and effort requires to perform a complete brute force attack against an encryption system is what a work factor or work function rating represents. The security and protection offered by a crypto system is directly proportional to the value of its work function or work factor. So, when we have to choose between crypto systems, we generally talk in terms of work functions or work factors, that how many how much time or how many days or years will it take to break the system. So that gives us a fair idea as to how strong a particular crypto system is. Importance of security of the key itself. So what we are encrypting our data with is the key, and the security of the key is a very important aspect of cryptography. Cryptographic keys provide the necessary element of secrecy to the crypto system. Modern crypto systems uses keys that are at least 128 bit long to provide the adequate security. This will change with the technology involved and emerging, like quantum computing will have altogether a different concept in the key management. So coming to the core cryptography, what we use in our networks every day, when we know that there are primarily two type of crypto systems in use. First is the symmetric and the other is asymmetric. The advantage of symmetric is it is faster. The disadvantage is sharing of key is a problem. Key distribution is a problem. In asymmetric, it is very easy to distribute key. It is stronger, but the disadvantage of asymmetric is that it is slower. It is very slow. When we are using asymmetric systems, the encryption and decryption takes much longer time, and when we use symmetric systems, it is much faster. Other advantage of asymmetric system is that public-private key pairs for communication between parties. It supports scalability, easy key distribution, and non-repudiation. So we know about confidentiality, integrity, and non-repudiation. So that is one of the major goal of cryptography is confidentiality. It does definitely aids to integrity. It provides the recipient of the message with assurance that the data was not altered. and between the time it was created and the time it was accessed. And non-repudiation provides undeniable proof that yes, this is the sender. So all these three things are met when we are using cryptography. Few of the symmetric cryptographic models are electronic code book. It is the simplest and least secure mode. It possesses 64-bit blocks. So yes, this I will be showing you a table. You would have to remember how what is the block size of ECB or CBC or CFB and OFB. So they are sometimes asked in the exams. So the block size, mostly the block size, and the basic things like is it a symmetric system or a asymmetric system, things like that. So ECB is the simplest and the least secure mode. It possesses processes 64-bit blocks. Encryption encrypts block. It's a block cipher with a chosen key. If same block is encountered multiple times, same encrypted block is produced, making it easy to break. Because the same block is coming again and again, it makes easier for the person to break it. Cipher block chaining. Each block of unencrypted text is XORed with the block of the cipher text immediately preceding it. So this is a little better. The complexity is going up now. You are using the preceding block and you are putting a mathematical model with the immediately preceding block. Decryption process simply decrypts the cipher text by reversing the operation. The XOR operation is reversed and you get the plain text. That is CBC. CFB is cipher feedback. Is a streaming version of CBC. So it's not a it's the CBC only, but the previous one, the CBC is a block cipher. This CFB is a streaming cipher, which works on the same model. It works on data in real time, uses memory buffers of same block size. When buffer is full, data is encrypted and transmitted. Uses chaining, so errors propagate. Whatever is highlighted is important for exam. Output feedback OFB operates similar to CFB but XORs the plain text with a seed value, with a random value. No chaining function, so errors do not propagate. So there are no chaining function, hence errors are not propagated. And counter uses an incrementing counter instead of a seed, so errors do not propagate in the counter also. Exclusive SOR option. XOR, or known as a binary addition, is used heavily in cryptography. Sounds more complicated than it usually actually is. The function of flipping bits is in a simple systematic fashion. So if the original value is 1 and key value is 1, the cipher value will be reverse, 0. If it is 1 and key value is 0, then cipher value will be 1. If the original value is 0, cipher key value is 1, then it will be 1. And if it is 0, 0, then it will be 0. So this is the XOR function, which is extensively used in cryptography. And this is how, at the binary level, this is the operation, how it looks like. So the biggest weakness in cryptography is a compromise of the key itself, right? If the key gets lost, then uh, uh, the entire message will get compromised. So the weakness in cryptography, where the plain text message generates identical ciphertext messages using the same algorithm but using different keys. So if we change the keys itself, we cluster the keys, we use multiple keys, then we can overcome this weakness. Coming to the asymmetric key types, we know there are two types of keys, public and private. The public is shared among everybody. Everybody has access to public key. The private key is kept secret with the private person. That's why it is private, right? Now, in asymmetric usage, if I have to send information to you, what type of key I will be using to encrypt the data?
Yeah, if you have to send, you use my public key.
Absolutely. If I have to send the data to you, I know that you have two pair of keys. I will use your public key because your public key is available with everybody, right? Everybody. But your private key is only with you personally and nobody else has it. So I will use your public key and encrypt the entire data and I will transmit it. The transmitted ciphertext will be going to the hacker also. I will assume it. And the hacker will not be able to decode it because hacker will require the private key to decode it, whereas you have the private key, so you will be able to decode it and hence the message will not get compromised. So that is the idea of having two pair of keys which are different. Key distribution is so easy because everybody can have your public key, right? There is no limitation. Even a hacker can have your public key. So there is not a problem of key distribution at all. You can have multiple pairs. You can change those multiple pairs every second, and but the private key remains only with you. So the public key has no limitation, right? It is open for everybody. So the exchange of keys is not a problem at all in case of a asymmetric type of cryptography. So public keys are shared among communicating parties and private keys are kept secret. The data to encrypt a message use the recipient's public key. So that is what I did. I used you are the recipient of the message, so I use your public key, and to decrypt the recipient will use his private key. In case of a digital signature, the objective is to authenticate that the message has been received by whatever you are receiving is from the correct source, right? So let me show a diagram. So let me show a diagram to understand digital signature. Now, what is our aim? Our aim is that first of all, any document which is digitally signed is something like a physical signature which has been replaced with a digital signature. Now, the document per se, the data per se is not encrypted. For example, you have a certificate which is digitally signed. So, certificate is not encrypted, but the signature which used to happen physically previously, now on top of that we are putting a digital signature. So what we are doing is, what the signer is doing it basically, what this is to be understood very with the first step is that if suppose this is a certificate which you've got, the signer will and the signer has his private key, right? So what he will do is he will calculate a hash of this data. Okay, he will calculate the hash of this data and he will encrypt the hash using his private key. Suppose yesterday we have done the hashing function. So suppose whatever data you will put in that hash function, you will get a fixed value output. So suppose you do a MD5 hash, it gives a series of zeros and ones. Now that particular data is a proof that this particular document is authentic, right? Because that is what the hash value is. It will always remain the same for this particular data, wherever you go in the world and use a MD5 algorithm. So this hash code which we have got, now I will be, as a signer, I will be encrypting that hash value with my private key, because the private key is specific, is only available with me, but my public key is there everywhere in the public, right? If I am a bank, suppose I am a bank, and this is a document, some very important contract. I have, what I've done, I've taken the contract, calculated a hash of that contract, and encrypted it using my private key, and then I have put that as a digital signature down below. So it's a open source document. Anybody can read it, plain text, and on down below there is this digitally signed document where you can see certain things. What is it? That is nothing but a hash of this particular document which is encrypted using my private key. Now this document has gone to everywhere in the world, right? It is available on internet. So this becomes a digitally signed document, and it has gone to everywhere in the world. Your concern is that the signer is an authentic person or not, and this particular data is in the original format and it's not manipulated. So I have two concern as a recipient, as a receiver, that so the signer is the correct person and not some fraud person, and that even if the signer is the correct person, the data should not be manipulated. So I have two requirements. So when I receive this document, the digitally signed document, what I will do is I will pull out this digital signature and I will decrypt the digital signature on that document using the public key of the signer. The moment I am able to decrypt it, I using the public key of the signer. The that is the authentication happens that the signer is the correct person, because his public key is getting validated. So the signer is correct. Now the next problem is that the information which has come, is it correct or not, or is it manipulated or not? So what I will do is I will pull out the information and calculate the hash of that information using the same algorithm. And when I have decrypted, I have already got the hash value because that's what was encrypted, right? So now the receiver will do a hash comparison. If the hashes are same, if the hash values are same, then it is also proved that the document is the same document. So both the problems are getting sorted out with the digital signature. Whenever a document is getting digitally signed, the the non-repudiation exists as well as far as the signer goes, because signer is getting validated, as well as the authentic integrity of the documents is also getting validated because the hash value is matching, right? Understood this?
Yes.
Mm. Oh, so this is another diagram. Sorry, this is the same diagram. This is another diagram which gives a little more detailed explanation in which they are using the correct steps. The previous diagram was not included the hash algorithm. So we have our original document, we did a hashing, we got a hash value, like we did for MD5, we got this value. I used my private key and I have signed the document. So this document is a plain text with a digital signature in the bottom. Now this gets transmitted. Now this digitally signed document has will take the digital signature, use the public key of the signer, and will get extract the hash. After you decrypt the message, you will get the hash. Now you take the document, again carry out the hash. If the hashes are matching, that is that proves that the integrity of the document is maintained and is the original document. As well as, since the public key is breaking the is opening the message, means that the recipient is also correct. So this is how a digital signature works. It ensures non-repudiation, as well as it does not provide confidentiality. You will be asked questions whether a digital signature provides integrity and confidentiality. A digital signature and non-repudiation. The digital signature does not provide confidentiality because the document is not encrypted. It is only the hash of the document which is getting encrypted. So it does not provide confidentiality, but it does definitely provides integrity and non-repudiation. So we know how, if a message needs to be transmitted, questions will come like this also. If the message needs to be transmitted, which key you will be using? You will be using the recipient's public key. If you have to send a digitally sign the document, then you will be using your own private key. So there is a different key which will be used based on the requirement of how you are going to be using it. So this is how it has been explained that Franco wants to send message to Maria. So what will he do? He will request for her Maria's public key. Since the key is public, Maria has no problem. She sends the public key to Franco. Now Franco uses the public key and encrypts the message using Maria's public key to and sends the message to her. The Maria uses her private key, and that's how since yeah, that's how the message gets decrypted. Hash functions we have already done a practical and we know what it is. It is for basically integrity requirements. So a good hash function has 5 requirements. They must allow input of any length, any amount of data, and it provides a fixed length output. The way we saw in MD5 example, makes it relatively easier to compute the hash function for any input. So it's a simple algorithm. Some algorithms will take file, some will take mostly it is a file which for which we are computing hash. So it will take a file, or you can type in some data and it can still give you hash. Why it's so the hash function is only a one-way function. It will give you a fixed length output, and it is only a one-way function, whereas a cryptography is a two-way function. A hash is always a one-way function. But the requirement of hash is it should be collision free. What is collision? What do we understand by collision in hashing?
Collision and hashing, my understanding, it's when you have um, the same plain text, two different plain text giving the same hash value.
Absolutely. So if the same hash value is generated by two different plain text, then there is collision, because our basic requirement is that the fixed length output should be different for different data, right? That's why that is what we are validating, right? So if the same value comes, then the whole purpose of the algorithm is lost and there is collision in it. So we hash should be collision free. So in MD5, in certain scenarios, it has been proved that collision exists. So that's why we have moved on to a more complicated hash algorithms like SHA series of algorithm, and we have moved away from MD5. So another thing about cryptography is use of salts. So that salts are used in password management. So attacker may use rainbow tables. Rainbow tables are nothing but previously defined tables like we do dictionary attack, in which the passwords are listed. Millions of passwords will be listed, and the attacker will do a brute force attack. It will just run those dictionaries, and if any of the password matches, then he will get access. In rainbow tables, it is exactly the same dictionary, but it is a hash of the passwords. The rainbow tables are hash of the passwords, and attackers use rainbow tables for pre-computed values to identify common used passwords. So commonly used password, they will make a hash out of it, and that hash will be used because that's what many of the access control technologies are using the password hashing, like in Microsoft. So the rainbow table attack is very common. So to prevent that, the salting of password is done. Salting is nothing but a random data that is added to the input in one-way function of that hash data and the password or a passphrase. So when you are storing your password in hashed format, some salt value, which is a random data, is added, so that the value of the password changes, and it does not remain a commonly guessed password or a commonly guessed passphrase. Adding salts to a password before hashing them reduces the effectiveness of rainbow table attacks. So we want to prevent the rainbow table attacks, so salting is done. So now we are coming to digital signature standards. Digital signature has multiple algorithms like SHA-1, SHA-2, SHA-3, message digest. MD is message digest. So we used to have MD1, MD5. All of them got compromised. They were collisions. So we moved on to SHA-1, SHA-2, and those are little complicated functions, but doing the same job. But the point is that collision is not there in them. It works in conjunction with one of the three encryption algorithms like digital signature algorithm, reverse Scheimer LD-man algorithm, and elliptical curve DSA algorithm. Now we understood how we can send a message using two different keys in in asymmetric cryptography. Now, how do we? So there is a problem in this also, that suppose I ask for your public key, right? What if the hacker sends the public key saying that he is you? So we know there is a man in the middle scenario. In this scenario, I have approached
Hey,
you and
Manny,
yeah,
can we take about 5 minutes break? You need to use restroom.
yeah, please sir, please. Let's take a 5 minutes.
All right, Manny, I'm back.
Yeah. So coming to a problem with sending and sharing of messages, we still have a issue that when I have to send a message to you, I need your public key, right? But
Yes.
what if there is a scenario that you have shared a public key and somebody has masqueraded and put his public key instead, and I have sent you the data in thinking that this is your key, right? That is a possibility. You got the problem?
No.
Yeah. So I don't know. I still have an issue with sharing of keys in which there is a scenario in which the public key can be manipulated in a way that I assume that it is your public key and I send the message to you. However, on your name, the hacker has sent his public key, and I don't. That is the only thing I have. So now I have used that public key, thinking that I am sending it to you, and the message is received by the hacker, and the hacker now uses his private key and decrypts the message, and the compromise happens. So to prevent that thing, what should happen ideally is that there should be one more uh, agency or a third party agency which is certifying that this particular public key belongs to you. If we introduce that trust factor, then this particular problem gets resolved. With me? Yeah, with me, sir.
Yes, I'm here.
Yeah. So now, if that particular authority certifies that this is this is the public key of a trusted person, and I'm certifying it, and I'm able to check that part, then the issue gets resolved, and now I'm 100% sure that the public key which I have received is correct. So all of this is happening automatically in your web browser. What is happening is, in your web browser, the CA's certification authorities public key is already saved. What the certification authority does, it issues a certificate. For example, you have typed www.google.com in your browser. So the request will go to the Google server. The Google server will not share his public key. He will share a digital certificate to your browser. It will come. Everything is happening automated. So the moment the request goes, the Google, before the session is getting activated, first is the certificate which reaches your browser. The browser already has the credentials of the certification authority, right? So the certification authority, what it has done is, it has taken your the Google's public key and certified it and encrypted it with the entire data with its own private key, right? And your browser already stores the is already having the public key of the CA. Now when this certificate comes, your browser uses the public key of the CA, takes out the data, right? Takes out the data, does the hash comparison of the public key which has happened, and compares that the public key which you have received is absolutely correct, and that is then your browser is 100% sure that the public key which has been received by you is of the Google server and not of a hacker. Once that is happens, the key exchange happens and the session starts. So to avoid a chance where incorrect public key is received by me, I am introducing one more third party, which is the certification authority, which is a trusted third party, and and there are multiple other functions which the CAs perform, the PKI functions perform, which we will be covering in detail. But this is the major thing. To mitigate this threat, to mitigate this vulnerability, we have used a third party, CA, the certification authority, to certify and then generate a digital certificates that contains the public key of the system users. The users then distribute certificates to people with whom they want to communicate. The certificate recipients verify the certificate using the CA's public key, right? That is how a PKI functions. Let me show you a PKI certificate. PKI. So there was a very nice diagram which used to cover all the activities which PKI does. I'm not able to find one second. Okay, that's. Hmm. Yeah, finally I'll find it. So let me put. Yeah. So we need a digital certificate. So we have a certification authority which is going to issue a digital certificate. So what are the components? The core components in PKI is certificate authority. It issues and digitally signs certificates to bind a public key of an identity. There is a RA, which is a registration authority, which is verifies the identity before the CA issues a certificate. There is a digital certificate. The certificate is now known as X509 standard certificate. It contains the public key and identity details signed by the CA. For example, the example which I gave about Google, it has the public key and identity details of Google in that digital certificate. There is a certificate repository which stores and distributes a valid certificate. There is a certification revocation list or OCSP. Basically, the certification is any certificate. It is valid for a defined time, right? Now, if that is expiring, if the certificate has expired, then it is put in a list called certificate revocation list. So the browser checks the certificate in with the CRL and doubly cross checks that whether the certificate is valid or not, or it has been put in CRL list or not. So this list revokes or invalidates the certificate. And there are key pairs, that is the public key which is shared and the private key which is kept secret, and the end entities which are user devices and application that uses the certificates. So this is the core component of the entire PKI infrastructure. It uses asymmetric cryptography for exchange of keys. And how it works: the browser connects to the website sends its digital certificate issued by the trusted CA. The browser then verifies the certificate validity and CA trust. The browser and the server uses keys to establish an encrypted session, which is a TLS handshake, and data is now encrypted, authenticated, and shared. The key function of PKI is authentication, that is verifying the identities, for example, servers and users. Confidentiality, that is encrypted the data in transit. Integrity, for example, detect changes in the data. And non-repudiation, to prevent denial of sending data or digital signature. So this is the most important thing which I have told you, because the questions will be coming from this aspect, that PKI is does it covers which all things. So it covers authentication, confidentiality, integrity, and non-repudiation. Any question in PKI?
No.
Right. So now we also need to secure traffic in when we are sharing via email, via web, and on the network. The technologies which extensively use cryptography and secures traffic on this on email, web, and network are pretty good privacy, S mine, which is secure multi-purpose internet mail extension. Yeah, I think that is what it is. Secure multi-purpose internet mail extension. This is a standard for sending and receiving secure, encrypted, and digital signed emails, and it is built on MIME standards, multi-purpose internet mail extension standard, which defines how to format multimedia emails and add cryptographic security using PKI. Again, the function remains encryption, digital signature, authentication, non-repudiation, and exchange of certificates and exchange of keys, right? So that secures the email. On the web, we use transport layer security, which has been replaced by SSL, secure socket layer, and the version right now, which the TLS version 1.3 has is being used nowadays. Recently upgraded. Earlier we were using TLS 1.2. On the network, we on the internet, we have started using IPSec protocol, which IPSec protocol standards provides a common framework for encrypting network traffic and is built into many common operating systems also. So a word about IPSec. IPSec is a security architecture framework that supports secure communication over IP. So any network which is using IP as a protocol can configure IPSec for for the security of communication, for securing the data in motion. So data has three stages: data at rest, data in motion, and data in use. So when we are using IPsec, we are ensuring that data in motion, the data which is moving on the network, is staying secure. So the different modes are also there. So IPsec, Internet Protocol Security. IPsec stands for Internet Protocol Security. It is a suite of protocols. There are multiple protocols which combine and make this protocol, and that secures IP communication by authentication and encryption at each IP packet in the communication session. So it works at layer 3, the network layer on the OSI model. So it can protect any kind of traffic like TCP, UDP, ICMP, etc. The main purpose is again confidentiality, integrity, authentication, and anti-relay. It has two modes, which is authentication header, two main modes or two main protocols, that is authentication header and encapsulation security payload, ESP, encapsulating security payload. In authentication header, it provides integrity, authentication, and anti-replay, and does not provide encryption. So this is very important, that AH does not provide encryption, and ESP is the one which provides encryption, integrity, authentication, and anti-relay. So it does it has two channels, that is transport mode and tunnel mode. In transport mode, encrypts the transport mode only encrypts the payload, whereas the tunnel mode encrypts the entire IP packet. So this is very important for you to remember for exam perspective, that the transport mode encrypts only the payload, whereas the tunnel mode encrypts the entire IP packet. And it has two main protocols, that is AH and ESP. AH stands for authentication header and ESP stands for encapsulating security payload. The difference is that in AH it is for integrity, authentication, and anti-replay, whereas ESP is also for encryption, integrity, authentication, and anti-replay. So that's the difference between the two, that will definitely be asked in exam. The key management in IPSec happens by use of IKE technology, which is Internet Key Exchange, to automatically negotiate keys and security parameters. So whenever the communication is getting established between the client and server, the negotiation of keys and security parameters happen, which happens in two phases. In phase 1, the establishment of secure authentic channel is done, and in phase 2, the negotiation of encryption keys or data is undertaken. It uses VPN, side to side or remote access, and secure communication between servers and devices over over untrusted networks. So the VPN connection is established, and that is all about IPSec. I think nothing more is required to be done from the CISSP perspective. Whatever is given in this slide is enough, and the questions will be asked from this one. So, what are the common types of cryptographic attacks? Now that we have understood cryptography, we know over email, web, and network, how do we secure our traffic using cryptography, what is PKI, what is digital signature standard, what is hashing, uh, how do we use asymmetric cryptography. Yeah, one important thing I have not covered is that whenever we have established connection, like whenever we have established connection, when we the key exchange is a problem, right? in case of in case of symmetric cryptography, in case of a symmetric cryptography, the key exchange is very is a problem, but symmetric cryptography is very fast. So how do I take the advantage of asymmetric and symmetric in a network? So when I have to initially establish connection, when I have to initially establish the connection, I will use asymmetric cryptography. I will do a key exchange. I will establish the session, and once the session is established, I know it is very slow. So what I'll do, I will exchange my key in this secure session which has been established. I will exchange the symmetric key, and then the payload will be encrypted using symmetric cryptography, because it will be either a stream cipher or a block cipher, but it will be symmetric because that is very fast. So I change over from asymmetric to symmetric once the key exchange has happened securely. Understood?
Yes.
Okay. So now that we have understood the cryptography and how we are securely sending the messages over, on the different circuits, what are the common attacks which we can encounter? We can surely encounter brute force, because brute force are attempts to randomly, yeah, anything. Brute force are the attempts to randomly find the correct cryptography key. So they want to compromise my key, because that is the only thing which is preventing the data from getting compromised. So they want to guess my key. So they will be keep doing the brute force attacks to break the key. So the known plain text, chosen ciphertext, and the chosen plain text attacks require the attacker to have some extra information in addition to the ciphertext. So this is one attack which we can encounter. There could be man-in-the-middle attack, which exploits the protocols that use two rounds of encryption. Right, multiple protocols we have seen where the keys are having the encryption keys are getting repeated. So when that is happening, it is easier for the hacker to guess that. So that's why the man-in-the-middle attack is possible. Man-in-the-middle attack pulls both parties into communicating with the attacker instead of directly with each other. So between the two main parties, there is somebody sitting in middle, and getting the information out of both the parties. Then we have birthday attacks, which is an attempt to find collisions in the hash functions, and replay attack, which is an attempt to refuse authentication requests. So these are the types of common cryptographic attacks which we may encounter. Anything which you want to know about these attacks, sir?
Um, Maybe if you can talk more about the birthday attack.
Okay, sir. Birthday attack is a type of cryptographic attack that exploits the birthday paradox. That means the name is because of so surprisingly high probability that two random inputs will produce the same output, a collision in the hash function, right? So suppose in a scenario, a company uses 128-bit hash, like MD5 is a 128-bit hash function, to verify document integrity. What will the attacker plan? They create two different files. File A contains with normal terms, and B, which contains with malicious terms. So there are two files created, A and B. They keep tweaking both the files. That is, adding extra spaces, doing metadata changes until both the files produce the same hash. So he is manipulating the files again and again, with the aim to produce the same hash. And the attacker gets you, the attacker will get you to the digitally signed file A. Because both files have the same hash, the attacker swaps it with file B and claims that you have signed it, right? So in file A now, it will be a digitally signed file A. He will be using it on the file B, and he will claim that you have signed file B also, because he could compromise the hash function. So that is one of the scenarios in case of a birthday attack, the way it will happen. In real world, MD5 and SHA-1 are vulnerable to this type of collision attack, That's why we are normally using SHA-256 or higher. Got
Thank you.
the yeah, yes, sir. So next concept we know is digital rights management. It allows owners to enforce restrictions on use of the content by others. All the content management companies I have now who are giving it online are utilizing the DRM systems. It commonly protects the entertainment content such as music, movies, and ebooks. It is occasionally found in the at the enterprise level, protecting sensitive information stored in documents. Whenever a document rights management is applied, it also helps in version control, change management, and stuff like that. So it gives a complete control over the particular file and how for the throughout the life cycle of that file. So that is very important. Throughout the life cycle of that file, this type of controls will assist in keeping it secure. So this is something which you need to probably mug up. Not, I mean, yeah. Questions definitely comes asking about what is the block size of uh, different types of symmetric algorithms. So in on the exam, this kind of data definitely is can be asked. Like blowfish uses which, what is the block size of blowfish, and or what is the block size of skipjack. So those kind of questions can definitely ask. So you can see that it will be easier for you to chunk the information and memorize it. Like most of them are using a block size of 64 bits, and only few like block cipher is using 128. Stream cipher does streaming, and RSA block cipher mode has multiple modes, that is 64, 32, and 128. And the two fish has 128. So other than these two or three, everybody rest is using 64. So this is how a skipjack actin looks like, and the name of the based on the name of this fish. So yeah, so when you multiply the blowfish into two, the skipjack comes. So you can see, sorry, when you multiply skipjacks by two, the two fish comes. So it is two, so two fish comes. So 64 into 2, 128. One of the random way, how can you remember that block size of skipjacks is 64, and by multiplying that by two, you get two fish. Similarly, there are multiple message digest hash algorithms which have been there. The MD series are having issues as far as collision is there. So we have moved on to SHA-256, which is as of now secure. So SHA-256 is the one which is in use. However, the older technologies or older algorithms, they are there. They can be asked in exam, and their hash value length can be seen. MD series has fixed 128, whether it is MD2, MD4, or MD5. Whereas in the SHA series, the advantage is that it the suffix is the same. The variable, the length of the output is same as the what is suffixed with the name. So SHA-224 is 224 bit variable. 256 is giving 256. Yeah, SHA-1 is 160. So that is how you can memorize the hash algorithms fixed outputs. So all the MD series are not in use as of now. The SHA-1 is secure hash algorithms. Secure hash algorithm 256 is in extensive use, and secure hash algorithm 384 is also used in digital signatures. So this thing I've already told you that whatever is the suffix in the name is exactly the same which is the output of it. So that's why it is easier for you to remember as far as SHA-2 series goes. So there are
So
three.
Manny,
Yeah,
sorry, Manny, you said SHA-1 is kind of replaced by SHA-2. So
yeah.
what is the variable length for SHA-2?
What are the
The variable length, the hash value
yeah.
length for SHA-2.
Yeah, so SHA-2 series is this entire series is called SHA-2 series. There are multiple
Oh, okay.
variants, right? So
Yeah.
224, 256. So what I was saying, it is easier to memorize SHA-2 series because whatever is the variable length, like if it is 224 bits, then the name itself contains that.
Huh. Okay.
Whereas in MD series, you will have to remember that everything is 128. SHA-1 is 160, but in SHA-2 series, what they have done is they have the nomenclature itself has the hash value length in it.
Okay.
Three major public key crypto systems which are in extensive use. That is RSA, Aljamal, and elliptic curve. The RSA is the most famous PKI, public key crypto system. It was developed by three scientists, Rivest, Scheimer, and Eldeman in 1977. It depends on the difficulty of factoring the product of prime number, the HCF, the highest common factor. And Aljaman is an extension of Diffie-Hellman key exchange algorithm that depends on modular arithmetic. It is less common in use than RSA in last several years. And the EC or elliptic curve has picked up now. This is an algorithm which depends on the elliptic curve discrete algorithmic problem and provides more security than other algorithms when both are in use with keys of same length. So if you have a key length or same key length and you are using RSA or Aljamal, elliptic curve would be more secure. It will be it is the most secure thing. So and it is picking up everywhere now. The EC algorithm is being changed with RSA. So earlier RSA was the most popular, and now EC has become more popular. Is being used. Then we talked about digital signatures in detail. It uses public key cryptography and hash functions. Aim is to digitally sign, replace the physical sign with digital sign. The document is not encrypted. The document is kept in the plain text only. Only the signature is digital, so it has the technology which ensures that the non-repudiation is there. That means the signed by the same person, and there is also integrity. That means the document remains. There is no tampering with the document. That is verified by using this particular technology. So it rely on public key cryptography and hash functions. Digital signature algorithm suitable for use in FIPS 186 for digital signature standard. So this is a standard of digital signature, and it must use SHA-2 series of hash functions. So we know what SHA-2 series is. Those four or five SHA functions which is called SHA-2 series. So digital signature nowadays must use because rest of the hashing functions have a issue of collision. So it may happen the scenario with the example in which I gave you, if somebody does a birthday attack and replaces an original document with a malified document because he could do a birthday attack. So to prevent that, we should use a SHA-2 series in whenever we are using digital signatures. Three currently approved encryption algorithms are DSA, RSA, elliptic curve DSA. So digital signature algorithm, which uses a standard known as FIPS 186.4, then RSA, which uses a standard ANSI 9.31, and elliptic curve ECDSA, which using ANI 9.64. They are currently approved encryption algorithms. So there are two technologies. One is hashing and one is encryption. In digital signature, you can use these three technologies for encryption and SHA-2 series for hashing. So we know that asymmetric algorithms, the popular one are RSA, which has been now getting changed with ECC, and ECC is considered to be really strong. El-Jamal and Diffie-Hellman moderately strong or not very popular type of asymmetric algorithms. So you should definitely be able to differentiate by whenever the name is said that okay, it is a RSA, Diffie-Hellman or El-Jamal, then you should be able to tell that yes, it's a asymmetric algorithm which is getting used, and that is important. So that kind of questions you can definitely expect in the exam. So let's take a 5 minutes break. Then we will move on to a different topic, which is security models, right? Different security models in use,
Okay.
right? Yeah.
Okay.
Any questions till now?
Ah,
I
no,
know
that's good.
it's a slightly complicated subject, a little boring also. So I hope the concepts which I have explained are clear to you.
Yeah, it is okay. I mean, you are decoding it the way it has to be decoded.
Thank you.
It's
Thank you.
just that I don't like those things, but for the exams, I have to sit down when they get prepared for that.
Yeah. Right, sir.
Okay, I'm back.
Right, sir. So now we are moving on to security model, and security model are used to determine how security will be implemented with subjects and what subjects can access the system and what objects they will have access to. So that's the pure requirement of a security model to keep the information secure, and in which there will be restrictions on the subjects. There will be restrictions on how what objects can be accessed to. They are the way to formalize a security policy, typically implemented by enforcing integrity, confidentiality, and other controls. Each of these models lay out broad guidelines and is not specific in nature. So, whatever is the recommended guidelines, they are broader in nature and not very specific. It can be tailored for the organization's requirement. It is up to the developer to decide how these models will be used and integrated into a specific design. Few of the security policies are issued by ISO, NIST, FIPS, and the models which we'll be also covering is Bella Padula, Biba, and state machine model. So what is the purpose? It provides a way for designers to map abstract statements into a security policy. They help you to generate your own security policy because they are the broad guidelines, and now you can modify them and tailor them to your own requirements. It determines how security will be implemented, what subjects can access the system, and what objects they will have access to. So one of the security model is a state machine model. In a state machine model, it describes a system that is always secure no matter whatever state it is in. Based on the computer science definition of a finite state machine FSM. A state is a snapshot of a system. So state is a snapshot of a system at a specific moment in time, and all state transition must be evaluated. In this model, all state transitions must be evaluated. If each possible state transition results in another secure state, from one state it transitions to another secure state, the system can be called as a secure state machine. Let's see an example of secure state machine. For example, is a ATM machine. It is ideal. ATM is waiting for the card. When the card is inserted, the state changes happen, and the card is inside the machine. Then you have to enter the pin. Again, the state changes. The user has to enter the pin. Then it comes into the authentication state. The user is verified. Then the transaction state, the transaction or the money withdrawal or deposit happens, and the card is ejected. So each transaction or each change of state of that ATM machine is evaluated, and if it is secure, then the overall state machine model is secure. Security rules in this scenario you cannot remove. So what are the security rules to ensure that the various states remain secure? The security rules are implemented are you cannot remove the inserted card. When insert the card, it leads till the time the transaction has completed. So this is one of the rules which have been implemented without going through the pin entered and authentication. You cannot move from idle to transaction directly. You will have to go through the steps. If pin verification fails, the machine must return to idle without performing a transaction. So if at the verification stage, if the state is failing, if the verification process is failing, it automatically rolls back to the ideal state, and all the transitions are controlled and verified. So what makes this ATM state change model secure? It is defined transactions only, no shortcut to insecure states. Access control checked by at every state. Error handling ensures rollback to a secure state if something fails. Right. So these are certain way a state control model is configured in the system. The next model is information flow model. Information flow model focuses on the flow of information. Information flow model are based again on the state machine model only. Like Bella-Padula and Biba model are both information flow model, how the information is flowing. In Bella-Padula model, you're preventing information flow from a higher security level to a lower security level is done. So they are all mandatory access control model, which is ensuring confidentiality of information. In Bella-Padula model, the models is to prevent the confidentiality of the information. The flow of information is controlled from a higher security level, for example, top secret level, to lower security level, which is a secret level. the information cannot flow from high to low, but from a lower security level, it can definitely go to a higher state, but not the vice versa. And BIBA focuses on flow from low to high security level. It prevents the flow from low state to high state, reverse of Bella-Padula. Both are confidentiality flow, information flow models, which are based on state machine model. Non-interference model. It is loosely again based on the information flow model. It it is concerned with the how actions of the subject at a higher security level affects the system's state or actions of the subject at a lower security level. It ensures that the action of different objects and subjects aren't seen by other objects and subjects, so they don't interfere with each other, and they are independent and in a non-interference way. So that is why it's a non-interference model, which is again based on information flow model. So there are some lattice based security models which are slightly complicated. It is based on interactions between combination of objects and subjects. So it's a complicated lattice based models in which how the objects and subjects are interacting, and the combinations of that will result in the state of that particular system. Objects such as resources, computers and applications, and subjects such as individuals, groups and organizations. Lattice-based models are used to define the levels of security of an object may have, and that the subject may have access to. So if we go for an example in this context, for example, a security level organization has security labels like top secret, secret, confidential, and unclassified. So it's a government or a military type of classification. If that is a scenario, in uh, in uh, in Bellapaludula confidentiality model, we will say that no read up, no read up, no write down. So NRU NWD, basically Bellapaludula says the model is a model which says that no read up and no write down. So you cannot read if you are at a particular level, you cannot read what is at the higher level. So somebody who is clear to access information cleared up to secret cannot read into top secret, and somebody who is cleared to an access to top secret cannot write into lower level, that is he cannot write to a secret. So that is the confidentiality focused model rule for Bellapalooza. So the scenario is Alice has a secret clearance, Bob has a confidential clearance. Alice can read documents marked secret or confidential but cannot read top secret, which is a level up. And Alice can write to secret and top secret document but cannot write to confidential or unconfidential, though he cannot write a level down. A lattice structure ensures that each label has a defined set of allowed interactions, and the dominance relationship between the labels controls the information flow. That's so why it is called a lattice, because you can mathematically represent all security labels and their relationships in a practical order, where each label has greatest lower bound and least upper bound, right? So there is where it is a lattice, the structure is lattice type of a structure is coming, and there is a complex relationships between subjects and objects, and what a subject can do with an object is very clearly defined. Security models, three properties that will be mentioned repeatedly when Talking about security models, simple security property describes the rules for reading. Star security property describes the rules of writing. And invocation property, rules around invocation calls such as to subjects. So mostly when we talk of security model, the governing backbone requirement is generally mentioned. For example, there will be an integrity model, there will be a confidentiality models. So when we talk of Bella Padula, no read up, no route down model, it is a confidentiality model. The aim of this particular security model is to preserve the confidentiality of information. On the other hand, the Clark-Wilson is an integrity model. The aim of the model implementation of the model is to prevent any unauthorized modification of information. So it is more focused towards integrity. So when we see the BIBA, Clark-Wilson, uh, Gaussian, Mezigio, or Sutherland, all these models, there are n number of such models, but the ones good for the ones which are relevant for exams, I have put on slide, and you need not definitely you should remember Bellapadula, Biba, and Clark's Wilson, and the others also you should know that which category they fall in. That should be enough for security models. You may expect one or two questions from this. So as we discussed about Bellapodula, it's a straight machine model which enforces confidentiality. It is also a lattice-based model. It uses mandatory access control, wherein it has a very stringent mandatory access control requirement. It's not discretionary, and it is mandatory. It has to be enforced to mostly used in the government organization like Department of Defense, where the requirements of multi-level security policy is there. Simple structure security policy is the subjects cannot read data at a higher level of classification, no reader, and the star security property, where the subjects cannot write info to lower level of classification, no write down. So it's important. The simple and star property of Bellapodilla must be remembered by heart. Multiple times in CISSP, the questions are directly asked about Bellapodilla. So just to remember a bell. On the bell, which this bell can be maybe anywhere. You see a bell, and on the left side it says no read up, and on the right side say no write down. So no running under nets with dingoes or any other mnemonic which you know which is easy to memorize. So in this scenario, you can remember no read up and no write down around a bell, and that's because the name is Bell Abdullah model. So again deliberating on the same model, the subjects cannot read on the higher security classification, and the subjects cannot write to a lower security classification. And BIBA is an integrity model. The main aim is to protect the integrity of information. So the simple property, integrity property, it has a simple integrity property and a star integrity property and invocation property. So in the simple integrity, it's again BIBA is a lattice based model uh, developed to address integrity concern. The simple integrity property has the subjects at one level of integrity is not permitted to read an object of lower integrity. So no read down. And the star property or integrity property is that objects at one level of integrity is not allowed to write to objects of higher integrity, no write. There is an invocation property which prohibits a subject at one level of integrity to from invoking a subject at a higher level of integrity. So simple property is read and star property is write. Right. So that is a BIBA integrity model. So let's assume an example for Biba integrity model. Suppose there are level 1, 2, and 3. Level 1 is for the in a medical record system in a hospital. Level 1 is for the patient self-reported data. Patients. Level 2 is the nurse, and level 3 is the doctor verified data. So integrity of data we are focusing on. So level 1 is the patient self-reported data. Whatever data the patient is reporting themselves is becomes the level 1 data. Whatever is the nurse and data entered by the nurse becomes the level 2 data, and whatever is the data which the doctor has verified and written becomes the level 3, the highest integrity data. So the lowest integrity is given to the patient record data, level 1, and highest integrity is given to the doctor verified data, level 3. So suppose Dr. Smith, which is at level 3, as per the model, he cannot read level 1 data directly to avoid being influenced by potentially inaccurate patient entered information. A nurse which is at level 2 cannot read the level 1 but can write to level 3 records. A patient who is at level 1 can update their own low level entries but cannot modify level 2 or level 3 records. So if this is the integrity model established in the hospital, so these will be the restrictions onto the subjects based onto the requirements of the integrity. So in this example, data integrity is preserved. High trust records are never contaminated by low trust inputs, and low trust users cannot override the high trust data. I hope after this example, this particular model must be absolutely clear, right, sir?
Yes.
So yeah, so if we show it in a form of sketch, then the subject does not have uh, read read cannot read the low or modify the lower classifications of data, and on the right hand side he cannot write onto the higher classification of data. So another integrity model is a Clark-Wilson model. It uses security labels to grant access to objects. It uses security labels to grant access to the objects. Constrained data item CDI is any data item whose integrity is protected by the security model. Unconstrained data item UDI is any data item that is not controlled by the security model. And IVP, integrity verification procedure, is a procedure that scans data items and confirms their integrity. And transformation procedure, TPs, are the only procedures that are allowed to modify the constrained data items. So this is the model in which all the data would be categorized, because we are it's a integrity protection model, so focused on modification of data and protecting the integrity of data. So let's see how it works. Suppose there is a payroll system in a company. The company pays salary to its employees every month. In the Clark-Wilson model is applied to ensure that the salaries are always correct, and no one person can both create and approve the salary payment. Right? No one person can create and approve. So this is the scenario. So element CDI, constrained data item, is employee salary database. The CDI item in this scenario is employee data salary database. UDI item, unconstrained data item, is raw salary input sheet prepared by HR. That is UDI. TP is transformation process. where the payroll program that calculates net pay, applied tax rules, and issues payments. So these are the TP, transformation procedure. So how it works? HR clerks prepare a raw salary input file, which is a UDI, which cannot directly change the salary database CDI. The UDI prepared by clerk cannot be directly changed in the database. It goes to the, it is getting validated by a payroll process, which is a TP. So TP validates this file, the UDI file prepared by the HR clerk. For example, it checks the employee ID, ensures no negative amounts and other stuff. Now the payroll officer runs the TP, updating the salary database, which is CDI. So the payroll officer has now updated the CDI, and the finance manager must approve the payment release, that is the separation of duties, ensuring no one person controls the whole process. So there is how a payroll process have been segregated using the Clark-Wilson model to ensure the integrity of data, because payroll data is the integrity of payroll data is really a concern and importance in the HR scenario. So in a Clark-Wilson model, integrity is maintained because all changes to critical data CDI happens only through TPs, trusted TPs, and separation of duty prevents fraud and accidental corruption. So access control triple or triplet is authenticated principal, that is a user or subject, programs, that is the TP, and data items, which is UDIs and CDIs, which are objects. So a relationship between an authenticated principal, that is the user, and a set of programs, which is TPs, that operates in a set of data items, which are segregated into two parts, UDIs and CDIs. That is how a Clark-Wilson model functions. So the next model is about take grant model. It is again a confidentiality model. It will be more focused on the correct person reading the correct security cleared data, and that is the primary confidentially based model that supports four basic operations: take, grant, create, and revoke. Take, grant, create, and revoke. The another model is Brewer-Nash confidentiality-based model. In a Brewer-Nash model is also called the Chinese wall. Multiple times these questions will be asked in CISSP. The Chinese wall model is A, B, C, D, E. So you should definitely know the Chinese wall model is Brewer and Nash model. It was developed to prevent the conflict of interest CIO problems. So let's see the example of Brewer and Nash model. So the scenario is an investment analyst works for a financial firm that serves multiple competing clients, right? An investment analyst works for a financial firm that serves multiple competing clients. Like company A is a tech company and company B is a competitor in the same sector. Same sector. So how this model will apply here? On a day one, the analyst accesses confidential financial data of company A. According to the Brewer and Nash rules, the analyst is now blocked from accessing sensitive data of company B because it would create a conflict of interest. So the analyst once has access to sensitive data of A, now cannot receive the sensitive data of B because we don't want conflict of interest. However, the analyst can still work with unrelated clients in the other industry, for example, an airline company, or because there is no conflict of interest exists. So that is to prevent the conflict of interest problems. This particular model is applied. and it is called a Chinese wall model. The reason why this name has come into existence as Chinese wall model, because it's based on a metaphor of Chinese wall. There is a barrier that separates two sides to prevent the flow of information, similar to the physical wall in ancient China that separates the territory. Uh, so the wall is logical here, not physical, and it prevents people from moving between sides so that conflicting interest does not arise. And it often used in financial services, counseling, legal, and journalism to prevent conflict of interest. Next model is Graham-Denning model. In Graham-Denning model, this model is used as a formal set of protection rules for which each object has an owner and a controller. This is focused on the secure creation and deletion of both subjects and objects, a collection of 8 primary protection rules or actions that define the boundaries of certain secure actions. So Graham-Denning model has 8 primary protection rules. That is very important to remember. There are 8 primary protection rules, and the model is primarily focused at secure creation and deletion of both subjects as well as objects. So knowledge, these are the 8 rules: securely create object, securely create subject, securely delete subject and object, securely provide the read access right, securely provide the grant access right, delete access rights, and transfer access rights. These are the 8 rules. Let's see a scenario in this thing also. I'll just take a 2 minutes break, sir. I'm getting a call. Yeah, so I'm back, sir. So yeah, so in this particular model, see a scenario. In this, let's there is a corporate cloud drive with 3 roles. A corporate cloud drive which have 3 roles. Alice is a product manager who is a user in the user role. Bob is a developer in the user role. File 1 is an object which is a project plan, and Carol is a system admin which is again having special authority. So it has a higher elevated authority, and there is one file called project plan. The Grand-Denning model defines 8 rules for secure object and subject management, like creating user, granting permission, deleting objects. So, in this particular scenario, grant access rights is given to the admin, which is Carol, giving Alice read-write access to file 1. The delete access rights after the project ends, Carol removes Alice's access to the file 1, right? So there is a delete access rights. Transfer access rights. Carol transfers Bob's read permission on file 1 to Alice. So the admin transfers the read permissions to Alice, and create object rule where Alice uploads file 2 to the cloud drive. Delete object rule, Alice deletes file 2, which is no longer needed. Create subject, Crawl creates a new user account for another gentleman called Dave, and delete subjects. Crawl removes Dave now because they are no more required, and change the owner. Crawl changes the ownership of file 1 to from Alice to Bob. So all of this access rights are defined. If we see when we were discussing RACI charts, the RACI charts are also doing a similar thing where what is the what is the responsibility of a person in doing a particular act. So that was at a very higher level, and this is very definitive. Very eight rules are there as to how a subject and object is to be treated in a system, right? To ensure that there is the security is ensured, right? Security and privacy. So dedicated mode security clearance that permits access to all info processed by the system, approved by all info processed by system, valid need to know for all info processed by the system. So that is a dedicated mode where all is very important, right? The keyword is all. Security clearance that permits access to all info processed by the system, approval for all info processed by the system, and valid need to know for all info processed by the system. A multi-level mode, on the other hand, can process information at different levels, even when all systems users do not have the required security clearance to access all information processed by the system. A system high mode is a mode where each user must have valid security clearance, access approval for all info processed by the system, and valid need to know for at least some info into the system, offers most granular control over resources and users of these models. System high model. Compartmented model goes one step further than system high. Each user must have valid security clearance, access approval for all info processed by the system, but requires valid need to know for all info they will have access to on the system. So these are further, defining that who has what rights and what all action. I mean, what all needs to be done to ensure security and privacy of information. So now we are moving on to a model called trusted computing base. This is a combination of hardware, software, and controls that work together to form a trusted base to enforce your security policy. You have a security policy, want to enforce it onto your entire enterprise, but you have been able to do it on certain set of combination of hardware, software, and controls. So that is your trusted base in your enterprise. It is a subset of a complete information system. Is the only portion that can be trusted to adherence to and enforce your security policy. So there is a parameter now, imaginary boundary, where you have been able to enforce your security policy. So that becomes a trusted base, and there is an imaginary parameter. Rest of the infrastructure is outside the trusted base. So now whatever is coming into this trusted base and whatever is going out in the same organization will be, now you will have to put some controls, because this is where you can keep more secure your information more secure, so you can keep more highly critical, sensitive and critical data or objects in this particular TCB. TCB must create secure channels like trusted paths to communicate with rest of the system, protects users like subjects from compromise as a result of TCB interchange. So TCB example is a iPhone secure enclave. For example, of a TCB is a iPhone secure enclave. It is a physically separated processor inside iPhone that handles sensitive information like fingerprint, face ID authentication, encryption, key storage, and secure boot verification. So all this sensitive information is inside your iPhone is stored at a place called iPhone Secure Enclave. Why it is a TCB? Because it's the minimal set of hardware, firmware, and software that the system must trust for security to work. So if so, that is a require. That is why it is a TCB. If it is compromised, the entire device security collapses, regardless of how good other apps are or designed. Right? Other examples of TCB in day-to-day life is ATM machines. The secure card reader plus encryption module inside the ATM machine that stores cryptographic keys and validates PIN is the TCB. If that is compromised, the entire machine is compromised. So inside that machine, the TCB of ATM machine, the TCB is where the card reader and encryption module is there. Cloud providers hypervisor. In this scenario, the AWS Nitro hypervisor forms a TCB for customer VMs. If it fails, isolation between tenants break. Right? Gaming console firmware. In a PlayStation, secure bootloader and OS kernel are the TCB to prevent privacy and cheating. So, in a particular system or a particular enterprise, this is the most secure area, most trusted area where you will be storing the most critical information, and the boundaries, the imagining boundary needs to be maintained with rest of the system so that the compromise do not take place. The reference monitor enforce access control. It is a logical part of TCB that confirms whether a subject has a right to use a resource prior to gaining access, prior to granting access. Security kernel implements access control. It is the collection of TCB components that implement the functionality of the reference monitor. So next is common criteria. TCSEC, ITSEC, and common criteria. Common criteria is given in ISO IC 15408. The common criteria enables an objective evaluation to validate that a particular product or system satisfy a defined set of security requirements. A common criteria enables an objective evaluation to validate that a particular product or system satisfies a defined set of security requirements like TCSEC. TCSEC is a trusted computer system evaluation criteria. It is one of the common criteria which is required for trusted computer system evaluation. A structured set of criteria for evaluating computer security within products and systems. ITSEC is Information Technology Security Evaluation Criteria. The ITSEC represents an initial attempt to create security evaluation criteria in Europe. TSEC uses two scales to rate functionality and assurance. CC, Common Criteria, has replaced or suspended both ITSEC and ITCSEC and ITSEC. So, what are the steps? Number one is description of assets, assumption of security policies. Number two is identification of threats. Number three is analysis and rating of threats, that is safety risk analysis. Number four is determining the security objective, that is system and environment objectives. And number five is selection of security functional requirements, and that goes in a cycle. So, two flavors: community protection profile CPP and evaluation assurance level EAL. EAL level, they will come ahead in the slide. It is important. EAL levels you must remember, because that multiple questions will be asked in EAL level. Yeah, so I think the moment I said, the next slide was EAL levels. So when we talk of TCSEC, ITSEC and CC description, these are the levels which you must be familiar with. For example, EAL level 0 and 1 means minimal or no protection. If we are evaluated, if a system is evaluated for EAL level 0 or EAL level 1, that means there is no protection or minimal protection. 2 is discretionary security mechanisms. Controlled access protection is level 3. Labeled security protection level 4. Structured security protection is level 5. And security domains is level 6. And verified security design is level 7. You may not remember the TCSEC and ITSEC codes, but uh, but the codes for EAL levels should be remembered by heart, because multiple questions are there which will refer to the EAL levels. So let's see example of these. So EAL level function means a basic Wi-Fi router sold for home use with one manufacturer's functional test. No, no deep design verification, just it works as advised. So that is a level 1. Level 2 would be smart card reader for building access in small office with limited but formal testing. So you've taken a smart card reader for building access in a small office, and with very limited but no formal testing. So that will go to level 2. Level 3 example would be where commercial firewall application like an entry level Fortinet firewall evaluated to level 3 has been implemented. Level 4 example would be a Microsoft Windows 10 or 11, certain editions evaluated for level 4, or Cisco ASA firewall in some government contracts has been evaluated to level 4, right? So these particular products will have EL level 4 certification or level 3 certification or level 7 certification. So when they say that this is a security certification to this level, that means you should be able to understand that level 4 certification means labeled security protection. Level 5 is smart cards used for government ID systems. For example, e-passports with EL level 5 certification. Level 6 example would be a hardware security module for banking system evaluated for EAL6. These hardware security modules will be saving some critical information, so there is a higher level of security certification is required. So these modules will be really expensive, right? So that's what it is. So the more testing and the better robust hardware is used, then the cost goes up, and obviously certification, getting it certified also is a costly affair. The last one is a level 7 certification. In EL level 7, example is specialized nuclear command and control system or military crypto modules. So this is the highest level, and it is generally, as the example says, is going to be used in a military grade kind of a setup, where you can't where you need a highest uh, level of security. Any questions, sir?
No, I think I'm good.
Yeah. So normally EAL level 1 to 4 are for commercial purposes, and EAL level 5 to 7 are used in government and military critical systems. That's the thumb rule.
Okay.
So the next thing is covert channels. In covert channels is a method that is used to pass information over the path that is normally not normally used for communication. Because it's not normally used, it may not be protected by the system's normal security controls. For example, covert timing channel and covert storage channel. So there could be some channel which is very hard to detect because it's outside the normal communication channels, and if those channels are used, there is always a risk that it will not have the security controls which is protecting the rest of the channels in the same way. So that's a security risk. A trusted platform module (TPM) is a chip that resides onto the motherboard of the device. Uh, it's a multi-purpose, like storage and management of keys used for full disk encryption solution. The TPM will be storing the keys which is used for full disk encryption of solution, and provides an operating system with an access to keys, but prevent drive removal and data access. So it's a multi-purpose storage and management key system. So now we are coming to a very interesting topic called access control, types of access control. We know there are mandatory access control, discretionary access control, non-discretionary access control, role-based access control, rule-based access control. Now, in the mandatory access control, enforces the access policy that is determined by the system, not the object owner. It is mandatory access control determined by the system, but not the object owner. It relies on the classification labels like that are representative of security domains and realms. In a discretionary access control, the owner or the creator permits the access, uh, permits owners or the creator of an object to control and define its accessibility, because the owner has full control by default. In a non-discretionary access control, it enables the enforcement of system-wide restriction that override object-specific access control. In a rule-based access control, it defines specific functions for access to request object commonly found in firewall systems. Certain rules are there, and based on that, the access is granted. So, diving deep into access control, a rule-based access control could be, a role-based access control could be use of defined job roles, right? To endow each one with specific permission, thereby seeking to ensure that users who occupy such roles can access what they need to get their jobs done. There is mandatory access control classifications like hierarchical environments, compartmentalized environments, and hybrid environments. In hierarchical environments, various classification labels are assigned in an ordered structure from low security to medium security to high security. In a compartmentalized environment, the requirements require specific security clearance over compartments or domains instead of objects. On the other hand, in a hybrid environment, it contains levels with compartments that are isolated from rest of the security domain. Combines both hierarchical and compartmentalized environments so that security levels have subcomponents. The key point about MAC is that every object and every subject has one or more labels. These labels are predefined, and the system determines access based on the assigned labels. Certification, the difference between certification and accreditation must be known. Certification is a technical evaluation of each part of the computer system to assess its concordance with security standard. A particular standard, like we said, EAL level 5, level 4, level 3, so that is a particular security standard. If if the system is evaluated for a particular standard, then it is certified. A process of accreditation is, on the other hand, the process of formal acceptance of certified configuration from a designated authority, mostly a government organization or somebody who has been nominated by the government. So acceptance of that formal process is accreditation. So generally, when we say the labs and etc., they are accredited because some of the any of the government body has certified that lab to have been following a standard. So this is called an accredited lab. Whereas the products are generally certified for a particular security standard or performance standard. So it is generally certified for that particular thing. Then coming to open and closed systems, what is the difference between the open and closed system? Open systems are designed by using industry standards and are usually easy to integrate with other open systems. So they conform to some particular standard. So integration becomes easy. A closed system uh, like Linux, example of open system, the best example is Linux. It is conforming to a standard and it is open system. Whereas any proprietary software would be a closed system because we really the outsiders don't really know the how it has been coded. So it's a closed system. Only the few people, the closed people, would know about it, and it will be very difficult to integrate a open system with a closed system, right? Because the standards will not match. So that's a closed system. Any proprietary hardware or software would form part of a closed system. Uh, Harder to integrate with other systems. Techniques for ensuring CIA confinement restricts a process of reading from and writing to a certain memory location. So if a memory location is confined, reading and writing would be difficult. Bounds. Bounds are the limits of memory or memory a process cannot exceed when reading or writing. So you're bounding it to a limit. Isolation, which made is the mode a process runs in when it is confined through the use of memory bounds. Coming to authentication, multi-factor authentication is using multiple factor. So it is very important to understand that uh, a password and you know when you say the factor for authentication, something you know, something you are, something you have. So you cannot use two different entities of the same factor and call it a multi-factor authentication. For example, for a iris scan and a fingerprint scan, factor is something you are, what you are made up of. So if you are using a fingerprint as well as iris and you say that we have done a multi-factor authentication, then that is wrong. So it is very important to understand multi-factor authentication in that spirit, that the factors should be different. Something you have, something you are, something you know. So password is something you know, a token is something you have, and biometrics is something what you are made up of, so something you are. So when you are using a multiple factor, the factor should be different, then only you can say it is a multiple factor. So normally we are using a password followed by a OTP which comes or a security token which we are already having. So those two different factors are used and then it becomes a multi-factor authentication. This concept is clear, sir?
Yes, it is clear. And I have a follow-up question because
Yep.
there are a lot of sites when you go, you have to put in your username and then your password, and then it lets you go. And they say they are MFA compliant. So that means they are not because that is all something you know.
Username, password, and
Yeah, and nothing. It lets you in
no,
because
no,
once you enter your username and password, then it lets you in.
no, 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 no.
That means
That
they are
is
not
not.
MFA compliant, right?
They are not admitted. See, when you are typing your username, what process is happening? Yeah,
It's
this will
just
be interesting. This discussion is going to be interesting because I generally do it with my students. So when you are typing your username in the website, just the
Mhm.
username, you have not entered a password as yet. So what
Yeah.
process you have done?
I mean, to me, entering that username alone, it's part of something you know.
No, no, no. Uh, okay. I'll reframe my question.
Okay.
Suppose we are let's assume that let's forget about the IT. Suppose you want to enter a particular colony, right? A particular apartment. So there is a security guard, right? And you are a authorized person into that apartment. So you have an ID card with you, right? Because you are authorized, so your ID card has been made. So but the security guard doesn't know you. So this security guard, this fellow will, you will approach the security guard and you will say that, I am an authorized person. So he said, I don't know you, right? You may be authorized, but I don't know you. I don't recognize you. So then what will you do? You will display your ID card, ID card. So that ID card, which has your photograph and other information, and he recognizes it, that is your initial phase, that is identification, right? Right?
Yeah, I
So in
understand. But what I'm saying is different. What I'm saying is I have a bank account that when I go into the bank account, I go to the bank website and then you click login and it tells you give your username. You put your username and then it goes to next. And then another screen comes in and says put your password. And when you put your password, yes, it takes you straight away to your account. You can access your account there. And that's what I'm saying. They are not following MFA.
No, no, they are not following MFA because they are single factor authentication. Just the password
Yes.
is the factor, and that is incorrect. If they are if they are calling it MFA, it is incorrect.
Now, yeah, that is all that I wanted to know. Yeah. Thank you.
But when we are discussing the access control and discussing authentication, we need to break the IAAA. The IAA is identification, authentication, authorization, right? So
Yeah.
identification is, so coming back to the example which I was giving, when you show your identity card, that gentleman doesn't know you. So when you show your identity card, you have done a process called identification because your identity card is you are what you are. If you don't show that identity card, the security guard will never recognize you, right? So same way the username in a system, your credentials are saved as username and password into the database. When you put your username, it is equivalent to showing the iCard to a security guard because your username is mapped to you. The way your iCard is mapped to you. So in the physical world, when you show the iCard and the security guard says, okay, fine, I know this iCard is authentic. Right, I will come to the authentic part, but he recognizes this iCard. That is where the identification has happened. So you are claiming to be an identity of a person by virtue of showing iCard. Same way you are claiming an identity of a person in your bank account by virtue of putting your username because your username is mapped to a particular account which has certain bank balance. Now the bank says or the security guard says that fine, this identity card is fine, but let me first authenticate. Let me authenticate. So he opens a register, he matches the serial number of iCard issued to you, and that serial number matches to the list of a list which he is having, and then he authenticates. He is authenticated it. Yes, this iCard is not a cloned or falsified iCard. It's a correct iCard. So same way, when you put the password, when you are putting the password, the bank website is saying, okay, this is the identity of a person, that is the username, mapped to an account having so much of balance, but I need to first authenticate. So what you do for authentication, you put your password. So your password is goes to the database with your username, it is mapped. with a password. Now the system authenticates, it verifies, it says yes, the credentials provided by this person matches with my database. And now the next process will be authorization. So the security guard in the physical world will say, okay, I have checked, authenticated, now you are authorized to enter inside. Based on your level of security clearance, you can now access the facility. So in this particular case, you are the owner of the apartment, so you have complete access. So we will let you inside, you will use your key and you will enter into your apartment. Same way in the bank website, when you are authenticated, you will be authorized to access the bank account and make a transaction. You will have authorization for a certain level, which is a user-based authorization. That means you can only do the transactions with your money, with the user level authorizations you are having. If you are a system administrator in the bank, you may have other higher level access, wherein you can check the accounts of other people also for the purpose of banking and maintenance. But at a user level, you have certain rights in which you can only access your account. So this technical process, which is generally driven from the physical world, in the physical world also to ensure security, identification, authentication, and authorization is done. Same way in the technical world, when you put username, you put password, and then you get the access to the level you are cleared. This IAA is undertaken to ensure, the correct person has access to the data. Now, in this process, in the entire process, when you use, when you are authenticating using two or more factors. When you are authenticating using two or more factors, suppose the bank says no, passwords can be stolen, you could have given it to somebody else. I will send a OTP onto a mapped mobile number. On your mapped mobile number, we will send a OTP which will be valid for next 3 to 4 minutes only. So now a SMS comes to your phone. You, in, in addition to the password, you put the code also. That is the time the bank is saying, okay, I have re-authenticated. I am not only authenticated by the password, I have also authenticated by OTP. And when I have put the multi-factor, two factors have been used. Suppose the bank says, I want to use three factors. Like in Google, suppose you travel to some other city and try to log in, it will say that somewhere you are is one more factor. It will say that you are accessing your account from some different location. Is it you? Then you say yes, I am. Okay, and go to your phone and again tick on the arrow mark. So they are, Google is now putting one more factor based on if you are trying to log into your access, if you are accessing your account from some different location, and then it will also pop up that yesterday you were at this so and so place, today you are accessing from so and so place. So all these factors are for authentication, for checking the genuineness of your identity. And once you are authenticated, the next step is authorization. Then you are authorized to access the resources and up to the level of your security clearance. Right, sir?
Yes.
I know this must be known to you, but I'm breaking it into steps because then it becomes absolutely clear what we mean by I, what we mean by A, authorization and authentication.
Yes.
Yeah. So something you know, that is PIN and password. Something you have which is a trusted device, something like a token generating device if you have, and something you are which is the biometric. Authentication and authorization. Authentication is a process of proving that you are who you say you are. Like your identity card authenticates what you say you are. So authentication is linked to your identity. It's a process of proving that you are who you say you are. And authorization is the act of granting authenticated party permission to do something. The access, basically granting access, is authorization. So a small step like walking up to security guard has divided into three small steps. Same way, entering your username, password, and entering a PIN is again broken down into these small steps. Then permissions, rights, and privileges are then granted to user based on their proven identity. If the user has right to a resource, they are granted the authorization. Permission, rights, and privileges are then granted to user based on their proven identity. If users have right to a resource, they are granted authorization. Authentication can be achieved with both symmetric and asymmetric ecosystems. So when you're talking of devices, when you're talking of firewalls, when you're talking of servers, when you're talking of switches, when you're talking of routers, they are not persons. Like how are they doing? How will they do this same process? They do the same process, but that is done technically using symmetric and asymmetric cryptosystems. Coming to the difference between multitasking and multi-threading. Multitasking is the simultaneous execution of more than one application on a computer and is managed by the operating system. Multi-threading, on the other hand, permits multiple concurrent tasks to be performed within a single process. Multiprocessing is a term, the use of more than one processor to increase computing power. And multi-programming is similar to multitasking but takes place on mainframe systems and requires specific programming. Single state and multi-state processors. Single state processors are capable of operating at only one security level at a time, whereas a multi-state can simultaneously operate at multiple security levels. User applications operate in a limited instruction set environment known as user mode. A privileged mode is a controlled operations are performed in privileged mode, also known as system mode, kernel mode, or supervisory mode. Coming to memory types, read-only, RAM, ROM, PROM, and EPROM. So read-only, static RAM, programmable chip, similar to ROM, and EPROM is erasing, clearing, overwriting unclassified data. Different types of memory types. There are two main subcategories of EPROMs, which are UV EPROM and EEPROM. Ultraviolet EPROM chips have a small window that, when illustrated within a special ultraviolet light, erases the contents. Electronically erasable EPROM uses electric voltages delivered to the pins of the chip to force erasure. A more flexible alternative to UV EPROM. Flash memory derivative derivative concept from EEPROM, non-volatile, can be electronically erased and rewritten. Primary storage is the same as memory. Secondary storage consists of magnetic, flash, or optical media that must be first read into primary memory before the CPU can use the data. Random access storage devices can be read at any point. Sequential access storage devices require scanning through all the data physically stored before the desired location. Three main security issues surrounding the secondary storage devices. Removable media can be used to steal data. Access control and encryption must be applied to protect data, and data can remain on the media even after file deletion or media formatting. Security risk to input-output devices, subject to eavesdropping and tapping used by to smuggle data out of the organization or used to create unauthorized insecure points of entry into the organization system and network. The purpose of firmware is a software stored on the ROM chip containing basic instructions needed to start a computer, also used to provide operating instructions in peripheral devices such as printers. Process isolation ensures that individual processes can access only the known data. Layering creates different limbs of security within a process and limits communication between them. Abstraction creates black box interfaces for programmers to use without requiring knowledge of the algorithm or device's inner working. Data hiding prevents information from being read from a different security level. Hardware segmentation enforces process isolation with physical control. The role of security process is to inform and guide the design, development, implementation, testing, and maintenance of some particular system. Cloud computing, the concept of computing where processing and storing of are performed elsewhere over a network connection rather than locally. Sensitive and confidential data can be at risk if the cloud provider and its personnel might not adhere to the same security standards as that of the organization. The internals, the cloud infra is not having the same standards of yours. A hypervisor are of two types, type 1 and type 2. A type 1 hypervisor is something which is on the bare metal, and type 2 is on the OS, which is on the OS, not on the base machine. Cyber hypervisor are native or a bare metal hypervisor. Generally, the question comes from hypervisor and CISSP, especially the difference between type 1 and type 2. A native or bare metal hypervisor is a configuration. There is no host OS. Instead, the hypervisor installs directly onto the hardware where the host OS would normally reside. In a type 2 hypervisor, the host hypervisor in this configuration, a standard regular OS is presented on the hardware, and the hypervisor is then installed as another software application. We've already understood is the access control. Security policy enforcement is done through CASB, Access Security Broker. Security of cloud provider concept in which security is provided to the organization through or by an online entity. Smart devices, mobile devices that offer customization options typically through installing app and may use an device or an in the cloud artificial intelligence or processing. IoT, a class of devices connected to internet in order to do automation, remote control or AI processing in home or business. Mobile device security, the range of potential security options or features that may be available for a mobile device. Security features include full device encryption, remote wiping, lockout, screen locks, GPS, application control, etc. Generally, MDM mobile device security management questions are like remote wiping and other controls which are available are asked in CISSP. Understanding the mobile application security. The application and functions used in a mobile device needs to be secured. Related concepts include key management, credential management, authentication, geotagging, encryption, application whitelisting, and transitive trust authentication. Bring your own device is a policy that allows employees to use their own personal mobile devices to work to access business information and resources. May improve employee morale and job satisfaction, but it increases the security risk of organization. Embedded system is typically designed around a limited set of specific functions in relation to the larger product of which it's a component. A static environment are applications, OS, hardware sets, or networks that are configured for a specific need, capability, or function and then set to remain unaltered. Both need security management. These techniques may include network segmentation, security layers, application firewall, manual updates, firmware version control, wrappers, and control redundancy and diversity. Privilege and accountability. Principle of least privilege, separation of privilege and accountability. Principle of least privilege ensures that only the minimum number of processes are authorized to run in a supervisory mode. POLP. Separation of privilege increases the granularity of secure operations. Accountability ensures that an audit trail exists to trace operations back to their resource, like having a log so that it can later on be traced back. Buffer overflow occurs when a program fails to check the size of the input data prior to writing the data on a specific memory location. In addition to buffer overload, programmers can leave backdoors and privileged programs on a system after it is deployed. Even well-written systems can be susceptible to time to check and time to use TOC/TOU attacks. Any state change presents an opportunity for an attacker to compromise the system. So time to check and time to use can be on the exam list, and it uses the state change, the vulnerability which exists when the state from one state to system changes another state. Functional order of security control deterrence denial detection delay. Thereafter determine and decide. Physical security controls can be divided into three groups: administrative, logical, and physical. Admin are known like site management, personal control, awareness training, emergency response, and procedure. Logical controls are the technical controls like access control, intrusion detection, alarm, CCTV monitoring, HVAC, power supplies, fire detection, and suppression. And the physical control for the physical environment like fencing, light, lock, construction material, access control like man traps, dogs, and cars. No physical access security requirement. Know the logical controls for physical security. Technical controls for physical security include access control, intrusion detection, alarms, CCTV and monitoring, HVAC, power supplies, fire detection. No administrative controls for physical security. Facility construction, facility selection, site management, personal control, awareness training, emergency response, emergency procedure. Physical controls, fencing, lighting, locks, construction material, man trap, dog guard. There is no security without physical security. There is no security without physical security. Without control over the physical environment, no amount of administrative or technical or logical access controls can provide adequate security. If a malicious person can gain physical access to your facility or equipment, they can do just about anything they want, from destruction to disclosure to alteration. So these are certain data which needs to be committed to memory, like fence 3 to 4 feet deters casual trespassers, 6 to 7 feet is hard to climb, and 8 feet and above barbed wire will deter the intruder. So based on the criticality and of the facility, sensitivity and criticality of your facility, you may choose what should be the height of the fence. Same way, temperature and humidity requirements ideal is 40 to 60 should be within 40 to 60% in your server rooms. Temperature of computer should not exceed should be between 15 to 23 degrees centigrade or 60 to 75 Fahrenheit. And damage is generally caused at 175 Fahrenheit. Manage storage devices damaged at 100 Fahrenheit. Electrical wire impacts are blackout, burnout, fault, surge, spikes, crack. Burnout question will definitely come out of this. You should know the difference between blackout, burnout, fault, surge, spikes, crack. Lights 8 feet height with 2 feet candela power. This is some information which should be memorized. Humidity and static electricity. Too much humidity can cause corrosion. If you are in a place which closer to sea or a lake or which is extremely humid, then there is a likelihood of too much corrosion. Too little humidity causes static electricity. On a desert area near closer to desert and all, static electricity can be a problem. Even on non-static carpet, low humidity can generate 20,000 volt static discharge. Fire suppression agents important. Class A, Class B, Class C, Class D, and K. Class A is for common combustibles like wood, paper, etc. Class B is for alcohol, oil, and petroleum products. C is for electrical fires. D is for burning materials, and are extinguished by dry powder. Metals, sorry. D is for metals, and K is for kitchen fires such as burning oil and this thing. You can use wet chemicals to extinguish it. For metal fire, you can use dry powder. For electric fires, you can use extinguishing agents which are non-conductive, such as any type of gas. And for burn from alcohol, petroleum products, should never use water to extinguish a Class B fire. You should use gas or soda acid. And Class A fire can be extinguished using water and soda acid. So again, classes of fire were not questioned will definitely come. A, B, C, D, K, common liquid, electrical, metal, kitchen, and suppression material. Normally in a data center, electrical thing, you will have halon or some product which is some gas which is approved, which will be used for data center or server room. Electromagnetic interference and noise. Electromagnetic interference is a common mode noise generated by difference in power between the hot and ground wires or the power source operating electrical equipment. The transverse mode noise generated by the difference in power in the hot and neutral wires of the power source operating electrical. So electromagnetic interference is also a big issue which needs to be addressed. Radio frequency interference is a source of interference that is generated by electrical appliances, light sources, electrical cables, circuits, and so on. Damage from fire and fire suppressions. Smoke, heat. Smoke is damaging the most storage devices. Heat can damage the electronic and consumer computer. Suppression mediums can cause short circuits, initiate corrosion, and otherwise render equipment useless. All of these issues must be addressed when designing a fire suppression system, or when you're picking up a fire suppression system. What could be the advantage and disadvantage should be well thought of. Pre-action systems like closed sprinkler heads. The pipe is charged with compressed air instead of water. The water is held in check by electrically operated sprinkler valve and compressed air. They are good for areas which have people and computers. Wet pipe systems are already filled with water, and dry pipe systems contain compressed air until the fire suppression systems are triggered, and then the pipe is filled with water and flame activated sprinklers targeted when a predefined temperature is reached. Dry pipe systems and deluge system are similar to the dry pipe system except the sprinkler head are open. Gas discharge system, halon system. Halon, this is important. Generally on glass discharge system, the data is asked. So FM200 is a substitute to halon. Argon, FM200 generally is considered to be a good substitute to halon. Because Halon has a problem of ozone depletion, so the we moved out from Halon to FM200. Types of locks: man traps, bollards, no key elements in site selection and facility design. For site selection, visibility, composition of the surrounding area and area accessibility, and the effects on natural disasters. For facility design, understand the level of security needed for your organization and planning it before constructing, but before the construction begins. Know how to design and configure secure work areas. There should not be equal access to all locations within a facility. Areas with high value assets require restricted access. Valuable and confined assets should be located in a heart or center of the protection provided by the facility. Centralized server or computer rooms need to be human compatible. Need not be human compatible. Threats to physical access control: no matter what physical access control is used, a security guard or other monitoring system must be deployed to prevent abuse, masquerading, piggybacking and tailgating. Know the security concerns of a wiring closet. There is where the networking cables of a floor or even a whole building are connected to essential equipment such as patch, panels, switches, routers, and backbone channels. Most security focuses on preventing physical unauthorized access. If an unauthorized intruder gains access, they may steal equipment, pull cut cables, or plant a listening device. Understand how to handle visitors in the secure facility. Restricted areas to control physical security, then mechanism to handle visitors is required. Often an escort is assigned to visitor and these access and activities are monitored closely. Tracking actions of outsider when they are granted access to prevent malicious activity against the most protected assets. Understanding the needs of media storage. Media storage facilities should be designed to securely store blank, reusable, and installed media. Concerns include theft, corruption, data remittance, recovery. Media storage facility protection include locked cabinets or sofas, using a librarian or a custodian, implementing a check-in, check-out process, using media sanitization. Evidence storage. Understand the concerns of evidence storage. Use to retain log, drive images, virtual machine snapshots, and other data sets for recovery, internal investigations, and forensic investigation. Protection of evidence storage include lock cabinets or safes, dedicated and isolated storage facilities, offline storage, access restrictions and activity tracking, hash management, and encryption. Audit trail and access logs. Audit trail and access logs are useful tools for managing for physical access control. Creation may need to be created manually by security guards or may be generated automatically with a right equipment like smart cards and certain proximity readers. Monitoring. You should also consider monitoring entry points with CCTV. Those CCTV, you can compare the audit trails and access logs with a visually recorded history of the events. Why are these important? Such information is critical to reconstructing the events at of an intrusion, breach, or attack. Need for clean power. Power supply by electrical components is not always consistent and clean. Most electronic equipment requires clean power in order to function properly and avoid damage. A UPS is a type of self-charging battery that can be used to supply consistent clean power to sensitive equipment. Supply power for minutes or hours depending upon its size and in the event of power failure. So that finishes the domain 3, and we take a little break, say 15 minutes break, if you are okay, sir, and then we start with the next section of training.
Sure. Okay. 15 minutes break.
Right, sir.
Okay.
Yeah, sir, I'm back.
Okay. I'm also here.
Right. So after doing, yes, sir. After doing the first domain, that is understanding the security and risk management steps, like CII tried in domain 1, CII tried security governance principles, compliance requirement like law, regulation frameworks, risk analysis, qualitative and quantitative, security policies, difference between security policies, standards, procedures, guidelines, business continuity and disaster recovery basics, and code of ethics, due diligence and due care, and domain 3, which is security architecture and engineering, where we have focused on security models like Bell Abdullah, Biba, Clarks Wilson, Brewer and Nash, Graham Dining, etc. Security capabilities and systems like trusted computing base and security kernel, cryptography, PKI, symmetric, asymmetric, hashing, digital signatures, physical security design, cloud security architecture, secure hardware and firmware, common criteria, and EAL levels. So we have actually covered quite a bit of uh, 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 into the certification, wherein we have spoken a lot about how security should be implemented at organization level. But it is extremely important to understand the requirements of securing the critical assets also, because eventually everything is a container. All the things, the IT is like a container, servers, networks, the information is just flowing in that container. The information per se is the gold mine. The data is the gold mine. So asset security as well as security of information cannot be, it will not be complete unless and until we focus on specific asset security. How do we secure our assets, right? So this is a shorter domain. It is a very short domain. So and it is a extremely simpler domain, because we now have done domain 1 and 3. So more or less things will be repetitive in nature. So I will be showing you the steps which you need to memorize. So this is a short presentation, and then I will be going on to another step wherein detailed slides are there. However, this particular slides which I am showing are extremely important from exam perspective, right? And you will find that most of the things are repetitive in nature. For example, in this domain, provisioning resources securely, manage data life cycles, determine data security controls and compliance requirement like DRM, CASB, DLP. So to start with, what is the life cycle of data, right? A life cycle of data is it is created, stored, used, shared, archived, and destroyed. So uh, the information cycle, it is focuses on classification of data, focuses a bit more on information protection, right? Unless and until you classify any created data, if it is not classified, then it becomes very difficult to handle that data. Because unless you give security classification, whether it is critical, it is sensitive, it is an average data which needs no protection, it will be very difficult to implement controls and safeguards to protect that particular data. So in your data life cycle, which is a cyclic activity, the moment it is created, it should be classified, then it should be stored securely, then it should be used, archived, and there should be a policy of destruction. Like after how much time a particular security classification data can be destroyed in an organization. There isn't a consistent standard used to identify each stage or phase of data lifecycle. Steps for how do we classify data? The moment it is created, we are supposed to be classifying it. So there are two classification standards. One is a non-government standard and other is a government standard. Normally questions come from this, that what is the equivalent of top secret in non-government, or what is the equivalent of confidential in government. So this should be memorized by you. And what, why it is top secret? Because it gives exceptionally grave damage. So that kind of questions will also come. There is a simpler domain, so the questions would be of similar nature of difficulty. So they will be asking similar type of questions, that exceptionally grave damage will get what type of security classification, then you should be answering top secret or confidential, right? Serious damage will be private and secret, and damage, some damage is sensitive and confidential, no damage is public and unclassified. So it is not level 1, 2, 3, 4, it is starts from 0. Please remember, it starts from 0, 0, 1, 2, 3, right? Not 1, 2, 3, 4. So for the examination, as I said, it is a shorter domain, a simpler one. All the things we have already discussed in domain 1 and 3 would be kind of repetitive over here. Same things will be applicable now onto the asset or data. Now identify and classify information and assets, determine and maintain information and asset ownership, protect privacy, ensure appropriate asset retention or destruction, determine data security controls which are going to be implemented, establish information and asset handling requirements like labeling, marking, chain of custodians, things like that, specific to the data and assets. Provision resources securely, manage data lifecycle, determine data security controls and compliance requirements like DRM, CASB, DLP. Security controls. So marking, labeling, handling and classification, right? You should know the difference between them. It will be asked in the exam. Difference between marking, labeling, handling and classification. Basically marking, labeling and handling. So what is the difference? With an example maybe.
Okay, for marking, it is kind of written, might be written on top of that data, or let's say in organization, if a data is marked as top secret, I mean, you see that marking top secret on it. Um, if it is also labeling as top secret, maybe um, on that cabinet or that file structure or the file folder, you will see a marking or something pointing, maybe a different color. Color red might be for top secret, showing that it has been used to label it. And then handling, yes, maybe you don't have to mix um, top secret and secret or no classification stuff together. So it has to be, we know top secrets are maybe on second floor, no classification stuff are on first floor. So that doesn't have to be, it doesn't have to mix. And then the classification also based on the content of the data, what the data or the severity of the data that will determine the classification.
Yeah, absolutely right. So, from the exam perspective, and just to remember it correctly, also, we normally know watermarking is when whenever taking printout, so it gets imprinted behind the printout, right? So,
Okay.
marking is something which is on written on the data. The
Okay.
classification we have already understood, seen that triangle in which there is top is secret, secret, confidential, and stuff like that. Now, when you have to do marking, that means it will be somewhere engraved on the data itself. That is called marking. Like on top and bottom of the page, there could be a confidential stamping, or there could be a watermark in which is a watermark behind the main content. So that is called marking. Whereas labeling is, uh, you know, it's on the top of the container which is having that data. For example, a CD case, earlier when the CDs were used, on the case you can mark, or on the file in which those printouts are there, on the file you can label. So there is a difference between labeling and marking. A marking is on the top of the data itself, and labeling is on the top of the container which is containing that data. Like metadata tag on the Word file says classification is equal to internal use only, or a barcode or a RFID label. So RFID is a label, whereas watermark is a mark on the data. So that's a key difference. So must be remembered. Then handling is how the data is to be handled. For example, confidential documents must be stored in a locked cupboard only. Encrypted restricted file, encrypting restricted files before sending via email. So how it should be handled, what security, what classification data is to be handled, how is the procedure of handling it. So that's the key differences between them. Then handling is shipping chain of custody, don't open boxes. So again, instructions which are written on how the data needs to be handled. Then data destruction, erasing and clearing. Okay, so what is the difference between erase, clear, purge? Erasing, clearing, purging. Of erase, clear, purge, and delete.
I think the line is breaking up a little bit. So
Can you hear me?
yes, it's now clear.
I'm asking that. This marking, labeling, handling, and classification is clear to you now? I mean, or did you miss something?
I think it was the handling part.
Yeah. So in the handling, it is the instructions are written how a data needs to be handled. How, like for example, when the instructions are written that confidential documents must be stored in a locked cabinet only, or encrypt a restricted file before sending via email. So those kind of instructions are for the handling the data. The
Okay.
classification triangle we have already seen, and labeling and marking difference I have already explained. Now what I want to know is the difference between erase, clear, purge, and delete. What is the difference?
You said the difference between clear, erase.
Erase, erase, clear, purge, and delete.
Okay. Erase will remove it, but it's not a permanent remove. And then clear, it also, huh, okay, let's go to page. Page is also gonna delete it, but again, it's not also a permanent delete. Somebody with a sophisticated tool can also get it back. And then I think delete, it's or removed, that is permanently.
Okay. So, so erasing is the generic term for removal or deletion. Okay, erase is a generic term for removal or deletion. Often means delete unless clarified. Not a formal sanitization method as per NIST guidelines. When you delete or erase, it just removes the file references, the pointers in all the data is indexed into your secondary storage, right, into your hard disk. So when it is stored in your hard disk, what a erase or delete function will do, it will remove the pointers to that particular file storage system, but the actual data blocks are still intact. It can be easily recovered using forensic tools. So that is why uh, a delete function or a erase function does not remove the data from the disk. Whereas clear function, when you use clear data, the data is overwritten or removed so that it cannot be recovered by standard operating functions or user level utilities. Right? When you use clear, it cannot be recovered by standard utilities. So single pass overwrite with non-sensitive data or using secure delete tools. So in the clear function, you probably do a single pass overwriting. You will overwrite with another data so that it cannot be recovered by basic utilities. You know, in a purge function, the data is removed so it cannot be recovered even by or advanced forensic tools. When you purge a data, it cannot be recovered even when you use advanced forensic tools. So it is very important that you understand the difference between erasing, clearing, and purging. Erasing is a basic function. You can easily recover with basic utilities. Clearing will you will not be able to recover using basic utilities, and purging you will be not be able to recover it in any which way. Okay, so that is how the data destruction terms are used. Record retention: if the retention policy is 1 year, it should be destroyed when it goes out of 1 year. Tape backup security: secure facilities, tapes, labels, ensure all understand the classification of data. So tape backup security means the backups which you have taken on tape, it should definitely be labeled, right? It should have label and handling instruction on top of it. right? It should have the labeling done, proper labeling. If a backup tape has a classification, a multiple classification data, for example, top secret is there and secret is there, what should it be labeled with?
Label as top secret.
Absolutely. The highest security classification, if there are multiple data, then the data which is the highest security classification should be labeled on top of that particular tape, backup tape. Yeah, so we discussed this erasing, clearing, purging, degaussing, and destroying. So degaussing is removing the magnetic field itself, and destruction is physical destruction. So this is a very important terms when we talk of the destruction of data, how it works. Erasing performs the delete operation against the files or media. Data is typically recoverable by when you erase or delete. When you are clearing, you are overwriting, preparing media for reuse and ensuring data cannot be recovered using traditional recovery tools. Purging, a more intense form of clearing that prepares media for reuse in a less secure environment. So, when suppose you are discarding a server, what should you do? And you have to discard it securely. What you should do? If
Yeah,
you
you have to follow um, data destruction procedure, or get a third party company to do that if you don't have the capability to do it yourself.
Absolutely. So that is very important. That if your server was a critical server, even if you have purged, if you want to use it now in a less secure reuse in less secure environment, then at least you should be purging. And if you want to just destroy or discard that particular server, then it should be at least degaussed, where the magnetic fields are to properly erased, and then destruction is physical destruction, right? So these are the ways you should be handling the data destruction methodology. And this will the exam will be testing you for this. So baseline, what is a baseline?
Baseline is the bare minimum to start with.
Absolutely. So baseline controls are the bare minimum controls to start with, and then you can make it better. But this should be the baseline, the bare minimum, which you should be starting with. If your baselines are not proper, then the environment is not safe. It's not secure. There can be breaches because the baselines are not in place. Be familiar with record retention and data destruction, right? For example, keeping data longer than necessary presents unnecessary legal issues. So, data protection, how do you protect critical and sensitive data? By encrypting it at rest and in transit. Whenever it is in rest and transit, it should be encrypted for protection. We know the security classification:
Yeah.
exceptionally grave damage, serious damage, damage, no damage. The asset classification should match the data classification. If you have a if you have a database server which stores top secret data, you cannot classify that database server as anything lower than top secret, because it should match with the data classification. Sensitive data is any information that isn't public or unclassified. So anything above public and unclassified becomes sensitive. The level of sensitivities are thereafter further divided. But you can't say that something which is you know restricted, or that is not sensitive. It is, because anything above public or unclassified is sensitive for the organization. Public, personally identified information, any information that can identify an living individual. It is not for organizations, it is for individual, personally identifiable information for individuals. And the name, birthplace, biometric records, social security number. Then personal health information is again for living individuals, where their health information should be kept, because of the HIPAA compliance. Most of the healthcare organizations have to handle it with care. So we have already discussed owner, custodian, steward, and those kind of roles yesterday. So a data owner is a person, usually a member of senior management, now who is delegating some day-to-day duties, but cannot delegate the responsibility. The responsibility of overall responsibility cannot be delegated. He is definitely, delegating some day-to-day duties to the custodian. A custodian is a person who is usually someone who is in the IT department, who do not decide what controls are needed, but does implement the decided controls by the data owner. So the decision maker for that particular role is the data owner, and custodian is just a technical implementer who has been delegated day-to-day duties. So whenever a question mentions day-to-day activity, then it is the custodian's responsibility, whereas overall responsibility rests with the owner itself. Can delegate and does not decide. So these are the two keywords. He can delegate it to custodian, but custodian is not the decision maker. He is just a follower. Based on the policy decided by the owner, he will just be implementing those policy on the data. Other roles which are important: data admins, responsible for granting appropriate access to personnel, often via role-based access control. User as any person who accesses data via a computing system or a accomplish work task. Business and mission owners can overlap with the responsibility of system owners or be the same. So basically, they can be the same as business owners, and mission owners can overlap with the responsibility of the data owner also. Asset owners are owns asset or system that processes sensitive data and associated security plans. So these are important roles when we talk of assets. In terms of GDPR, there is a data processor, there is a data controller, and there is a data transferer. A data processor, a natural or legal person, public authority, agency, or other body which processes personal data solely on behalf of the data controller. On the behalf of data controller. Who is the controller? Controller is a person or entity that controls processing of the data. He is the controlling entity, and processor is doing on behalf of controller. Data transfer: GDPR restricts data transfer to countries outside the EU. So, so this is again extremely important that GDPR has a very stringent rules if the PII or other sensitive data gets leaked. So to reduce the exposure, you can anonymize or pseudo-anonymize the data. You can do tokenism. For example, my social security number is, is a PII. Now, if I save my social security number, if I collect the customer social security number, then I have to be GDPR compliant. But I know that GDPR is a very stringent regulation. So how do I bypass that? So what I will do is I will anonymize that. I will not save it as a social security number. I will put a subsequent code and save it like that. And that code I can, that is tokenization. What I'm explaining. So that token value can subsequently be mapped with the social security number saved in a more secure environment whenever I want. So what I have achieved by doing that, I have reduced my exposure to GDPR. Even if that data gets lost, there is nothing which is getting violated because the key number, the social security number was never there. It was it was tokenized. Same way you can anonymize the process of removal of all relevant data so that it is impossible to identify the original subject or a person. Now I have a database. I produce one more database, remove all the anonymizes that database, and map it with some some code. So if I need at a later stage those relevant information, I can always reach out to that relevant information by mapping it with the thing which is in open domain. But at open domain, I have removed my exposure to GDPR. So these are the techniques which we can utilize, like anonymization, pseudo-anonymization. In pseudo-anonymization, the process of using pseudo-anonymous like allies to represent the data can result in less stringent requirement that would otherwise apply under GDPR. So, for example, be familiar with GDPR terms, data role, security controls. Okay, uh, for a breach, normally, for a breach for GDPR requirements, a notification should be made within 72 hours. Okay, notification for data breach. The GDPR requirement is to notify all the stakeholders within 72 hours of the breach is mandatory. Otherwise, there will be some punitive action taken against the company. So this is the
So, money.
yeah
I got a question. Can you go back to the notification for GDPR, please?
yeah
Yes. So you said it stated here clearly you have to notify um, stakeholders within 72 hours of a data breach. That is GDPR. What
yeah
about situations in the US where
situations.
there's a, yeah, situation in the US where there's a data breach? How many hours do you have to notify like customers or other stakeholders?
Okay. Okay, database notification requirement in US, right?
Yes.
Okay, so yes, it will it will depend basically on mostly state level laws. Okay, this
Okay.
notifications is to be done is basically state level laws. For example, 50 states have breach notification laws. If the PII is breached, the organization must notify affected individuals, notify state regulators in some states like New York and California also, notify credit bureaus if over a certain threshold of affected people are there. Common requirements are notification without unreasonable delay. So this is not defining the timeline, number 72
Okay.
hours or something, but it says unreasonable delay. Some state give exact timelines like 30 or 45 days. Notification in plain language explaining what happened, what data was involved, steps involved to take action taken, and contact info for credit agencies. This applies to unencrypted PII. If encrypted or keys are not compromised, usually there is no requirement. If it was encrypted, then there is no requirement. State of California has a regulation which is California Consumer Privacy Act, code 179882. It must notify as quickly as possible and without unreasonable delay. Specific formatting for large breaches like greater than 500 residents with with a sample notice posted online. Right. So that is how different places have different guidelines. For example, for HIPAA, in for a HIPAA compliant organization, the it is defined to be 60 days. For GLBA, as soon as possible. For safeguard FTC safeguard rule expands to non-banking financial entities, and FISMA federal agencies must report to DHS. So that is how the requirements are there, right, sir? Yeah. So now these are the important topics for in this particular domain, which are extremely important. Means each of this slide is important for memorizing in for the exam purpose. Now I will be flashing a journal presentation which I had prepared for overall understanding of the domain, so that I will be going fast. But this is the critical, this is the most important things which you should definitely know, right?
Right.
Yeah. So same domain too. They are a little more text, same stuff, and I will be going a little fast and covering the key concepts I have already covered. So wherever you have any issue, please stop me and ask me, right? So objectives of this domain is asset classification, data classification, knowing about information and asset handling requirements, learning about secure provisioning of information and assets, examine information and asset ownership, and explore asset inventory and management. Right. This is how this particular domain is being structured. A relatively small domain. So we know the classification of asset. There are certain standards which are given for which can be used for asset classification, like International Financial Reporting Standard Framework defines an asset as resource controlled by an enterprise as a result of past events or from which future economic benefits are expected to flow to enterprise. So that's the definition of an asset, and generally have three main attributes. It has a ownership. Specific assets signify possession. Assets signify possessions that can be ultimately converted into cash or cash equivalents, economic value, and resource. Assets are possessions that can be leveraged to produce future economic remunerations. We have types of assets classification: convertibility, physical existence, and usage based on utility. Convertibility, current asset, fixed asset. Physical existence like tangible asset and intangible asset. And classification based on utility like operating asset, non-operating assets. So when we say asset, and non-information assets can be critical and non-critical. Information assets can be business critical or personal data like PIIs. So there are different categories in which we can categorize our assets. Some examples of intangible assets. Yeah. So the difference between this are sometimes asked, right? What is the difference between patent, copyright, trade secret? goodwill and trademarks. So you licenses and franchises. These are sometimes asked in the exam. Okay. So patent is an exclusive legal right granted by a government to an inventor. So patent is associated with generally a inventor who has invented something great, right? The and it is usually for 20 years. The duration of patent is for 20 years. It is very important for you to remember that a patent duration is normally for 20 years. For example, Apple's patent for iPhone multi-touch interface, it is for 20 years. A copyright is a legal right given to a creator of original work, normally an artist or somebody who's music or software code, like copyright. So copyright is usually it is given for the living life of the author plus 70 years.
Money. So
Yeah,
you said the patent, it's normally 20 years duration. So
yeah,
after the 20 years, do you renew it?
yeah. You can renew it, but initially given for 20 years only.
Oh, okay. 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 Yeah. So after that 20 years, you renew it so that you still have the exclusive right.
Yeah.
Okay. Thank you.
A copyright will be for the life of the author plus 70 years, mostly for digital artistic artist people like who have written a poem or created some music, maybe a software code. So there is a copyright. For example, J.K. Rowling copyright over Harry Potter books, right? So they have J.K. Rowling have a copyright on the Harry Potter book. It will be for his entire life plus 70 years. A trade secret is something having business value. For example, a Coca-Cola formula. If that gets lost, then the entire business is lost. It will be a very big financial impact. So that is a trade secret, and its duration is lifelong, forever. It should never get leaked. A goodwill is an intangible thing, an intangible asset that arises when a company buys another or more than the fair market value of its net worth. Okay, so it exists as long as the business keeps its reputation. The duration of goodwill is as long as the reputation exists for the business. A trademark is a logo, it's a sign, it's a logo, name, or a symbol, and it can last forever. A license is a legal permission to use someone's intellectual property. A legal permission to use someone's intellectual property IP under certain conditions. The duration is as per the licensing agreement. For example, a Windows OS uh, has a licensing agreement. You can use it for a certain duration as far as the agreement is. A franchise is a business model where a company lets another person use its brand. Franchise is a business model where you can use the other company's brand, system, or product by paying a fee. The duration is based on the agreement, again based on the agreement. So understand the difference between the different intangible assets and what is the duration they will last, that is asked in the exam. So key ones are patent, which is for 20 years, and copyright is for the life plus 70 years, right? So we did the data classification in that triangle. Commercial classification is public, internal, confidential, restricted. What does the restricted data mean? It's a
Um,
sensitive. Yep.
okay. Yeah, I was gonna say restricted data means due to the classification level of the data, it is sensitive and only people with that kind of authorization can have access to it. So if it is a top secret, if you don't have top secret clearance, you can't have it. So it is restricted.
Yeah. So unauthorized. So what is important from exam perspective is the highlighted line. Unauthorized disclosure would have a major financial or legal impact on the enterprise. That is a restricted data as far as this particular classification goes, which is at the topmost level, right? The topmost level. Only need to know basis. It should be allowed for only need to know basis, and normally there should be a NDA signed wherever this information is shared, and it will have a major financial impact to the enterprise. Confidential data could negatively affect, right? Could negatively affect. Internal data, if disclosed, has a minimal impact on the business. Uh, Minimal impact, and public data will have no impact. So when we are choosing the control, we can see that for the public data, even if the controls are not put, I mean, although it's not the best practice, but still, when if the organization is financially constrained, it can take a decision based on this data classification and what type of control they are going to select to protect that kind of data. So Department of Defense have top secret, secret, confidential, and unclassified, right? The unclassified. So there are four in that, and they are comparable. They can be compared in the sense when we can compare. So generally the questions will come that what is a top secret equivalent in the civil domain, and what is a that equivalent in the government domain. So that kind of questions are also expected in the exam. So information and asset handling requirements. The first requirement of handling information and asset is taking a complete inventory of hardware components in use and stored as a hot spare. This includes servers, workstation, endpoints, infra devices such as switches and routers, and any other physical appliance or modular component that are deployed or deployable. Remember, wireless devices and multifunctional appliances as well. So you need to make a database of assets. Most important activity is to have a database of the assets, whether they are tangible or intangible. Tagging and labeling we have discussed in detail. Put a tag. A tag and label is written on top of the container, and tagging is a external tape or a physical thing which is attached to that particular thing. So asset tagging or labeling for unique identification, make and model and serial number should be mentioned on top of that. Initial cost and depreciation, what are the specification, physical location, owner, who is the owner and custodian, very important. When you are making an asset database, the ownership should definitely be there. Apart from the other things, this is the most important because it is the owner who is responsible for keeping the that asset in the security of the asset eventually. So the overall responsibility is for the owner and the custodian. Who the owner would have delegated that responsibility is the custodian, right? So who has the ownership and who is the custodian of that asset should also be documented in that database thing. Tagging and labeling we have already discussed. So how do you do tagging and labeling? By putting uh, universal product code, QR code, putting a RFID or NFC tag, right? Software application should be labeled by usage, version number, license information, and the number of users. The data is typically stored in a configuration management database. In a cloud environment, using key value pair tags. So tagging is to be done. That is extremely important. Secure provisioning of information and assets. Keys, certificates, database secrets must be protected as soon as they are generated until integrated into each device. So the things like keys, certificates, database secrets, they are the ones which if they are disclosed, then they will have a direct impact on the overall security of the asset. So such kind of critical data should be immediately protected. Secure hardware provisioning. So in that entire setup, your hardware secure model or HSM will be securing the security related info like keys, the secret keys, the certificates, and licenses. Those information may be stored in the HSM. So you have to be ensuring that the critical hardware things are secure or not, like secure bootloader, your HSM, and other things which are having a direct impact on the overall security of the hardware setup. This is a flowchart how asset provisioning is undertaken. So it starts with a proposal, then standardized asset onboarding. The ownership is defined, the ownership is accepted, and eventually it goes through the cycle and then it is approved. Physical asset ownership, mobile management device, enterprise mobile management environment, which is permitting BYOD. So assets that may be employee owned, can be cell phones, laptops, vehicles, recording equipment, pads, workstations, printers, headphones. Tangible asset inventory, raw materials, goods in process, finished products. The example of one of the examples. Add the serial number of the device, date the device was imported into your admin console, type of device, for example, Android or this thing, asset tag or ID that's assigned to the device, and the status. This is how records needs to be asset inventory needs to be maintained. For an intangible asset, maintaining an inventory is difficult but necessary. Intangible is something not capable of being touched or not having a physical substance. Name recognition, reputation, goodwill, all these are intangible assets. So placing the value on the intangibles is also not so easy, but it's not objective but subjective. So when we were having a discussion on making an asset inventory for risk assessment, and we were generally discussing that why should we even think of quantitative when we have qualitative with us. So these are the challenges because of which we cannot define a dollar value, and there is where subjectivity comes into the domain, especially with the asset valuation goes, right? So when you have to define intangibles, there can be a price approach, but that is just an estimate. The marketplace approach, by comparing the intangible assets owned by other similar businesses or industries, or the revenue approach, like. So asset management is given in the ISO. As per the ISO, systematic and coordinated activities and practices through which an organization optimally and sustainably controls its assets and asset systems. This includes their associated performance and risk and expenditure over their life cycle for the purpose of achieving a defined strategic plan. Asset management is the overall long-term plan for an organization. Effective implementation of asset management requires a disciplined approach which enables an organization to maximize value and deliver its strategic objective through managing its assets over the whole life cycle. So some examples how asset management life cycle looks like. So data life cycle controls and compliance. Data can be in three states: at rest, and transit, and use. When it is at rest, the file or object is resting on the drives, arrays, databases, and memory cards. When it is in transit, it's on the network. It is moving across the wire, wireless, PAN, cellular, and satellite networks. And when it is in use, it may be in the volatile state in CPU registers, RAM memories, swap files, caches, and clusters. So these are the three states of data: compiling and approving data glossaries, schema, and defining sets. So again, coming to the activities which a data owner should do is to compile and approve the data glossary, schema, and define sets, managing functions that are relevant to data quality and accuracy, certifying information use inside and outside the organization, appraising and approving the master data management strategy, tactics, and activities, working with other data owners to resolve issues and misconfigurations through business functions. The custodians who have been delegated the due to the technical skill set some of the responsibilities, day-to-day responsibilities. In some areas the data custodian is referred to as a controller also. Like in GDPR, the custodian will be termed as a controller. The data custodian is often responsible for developing and maintaining technical and security controls for certain data collections. They ensure CIA authenticity, availability of data and assets. The goal is to support and fulfill the data governance framework standards established by the data owner. Keyword here is established by the data owner and officers. So he is doing on the behalf of the data owner. A steward is a maybe the subject is a person who is a subject matter expert in that the data conforms to a particular standard. Whenever it is leaving the organization or entering the organization, it should be following a particular standard. The primary difference between the data owner and a data steward is that the data steward manages the quality of the defined data set daily and is more customer focused, internal or external. Data steward are the subject matter experts who understands and can describe the importance of the information and its regular use. A data steward regularly teams up with other stewards within the organization for various projects and programs in the Data Steward Council. Users and processors, day-to-day use in the organization, like salesperson, managers, human resource people. So this we have already done. Collection, location, maintenance, retention, and disruption. The life cycle of the data. Collect the collected data can be structured, semi-structured, or unstructured. Other activities include labeling, tagging, categorizing, handling, ownership, custodian. So basically, the inventory of data needs to be updated and maintained, in which all these activities needs to be. So ownership of data is definitely should be defined. So whether it is a asset or it is a data, whether it is a tangible asset or intangible, tangible or intangible asset, the ownership and custodianship if not defined, it will be very difficult to fix accountabilities in when there is a breach happening. The moment the breach happens, the first thing asked is who is the custodian or who is the owner of that particular asset, whether the patch management or change management were done when the modifications were undertaken. So these are some legal requirements, these are some necessary requirements, and even you need to know the who is the owner or custodian, because when you are selecting the control, the security classification itself is done by the owner. The technical people don't know what security classification that data holds, that asset holds. So the security classification, whether this is a sensitive asset or a critical asset to the organization, that classification itself is defined by the owner. So we need to know who is the owner or custodian. This is the most important thing, where most of the organizations don't follow, and later on when there is a breach or when there is a disruption or a outage, then they are struggling to find that who the responsibilities, who to fix, who should be blamed for it. So that's the issue across the enterprise. First party, second party, third party, collected directly, data shared by another organization about its customer, and third party data that has been aggregated and sold. Right? These are the three types of data collection generally happens. So these are some of the methods data is collected. Location, it's a optional phase. Storage, data in block, volume, file, or object storage. Right. So the location use case. Maintenance. Data maintenance is supported by GDPR concept of data minimalization. Minimalization is only having the minimum data which is required for the process, so that the normally when we have when we generate databases, we'll have some 20 fields, 30 fields. That is not required. We need only the data which is required for the job. So minimalistic approach in gathering data will avoid compliance requirements like GDPR. The only data that should be maintained is the data that has utility value and is meaningful. Right? Data maintenance is also called processing. It involves encryption, wrangling, compression, processing, and analysis. Data maintenance and management activities will have raw data, data appended, cleaned, deduplication, verification, validation, segmentation, and hygiene and maintenance. So when the cleaning has done, then we say it's the updated data. When the verification has been done, we say it's a correct data. And the segmentation is done, then we say it's a complete data. Data should be retained according to the best practices. Policy, security governance, laws and regulations may mandate data retention up to some time. For example, many of the companies would say that the CCTV data should be for at least 60 days or 30 days. So some policy exists. So based on that, that may be mandated by the local law. So retention generally refers to a long-term archiving as opposed to the location and storage. Certain remnants in a situation which, when warrant, when remnants, fragments, or artifacts of data can be recovered even after proper wiping or erasure. Data remnants make sensitive information vulnerable to unethical hacking and data theft when the organization supposedly disposed of, transferred, resold, or stored data on various media formats. So data remnants is an issue, and we should be really careful about the remnants. If the asset used was really critical, high security classification asset, then we should be really careful when we are disposing of that asset. End of life and end of support. Determining data end of life and end of support. The flow chart which can be referred to determine data end of life and end of support. Media destruction. As per the NIST, media sanitization is one key element of assuring confidentiality, because if you have not sanitized the media which is going to be destroyed, then the sensitive data can be recovered and misused. Confidentiality is defined as preserving authorized restrictions on information access and disclosure, including means for protecting personal privacy and proprietary information. Additionally, a loss of confidentiality is the unauthorized disclosure of information. Overwriting, degaussing and wiping, and physical destruction. What is crypto shedding? What is crypto shedding? Hi Ken, are you there?
Yeah, I'm here, but I don't know crypto trading.
Okay. Crypto shedding is so it's an important term. You must know that. Okay, suppose you are in a cloud environment and you are vacating that cloud. I think I gave you that example. So now somebody else will be coming to and using the same servers, right? So
Okay.
cloud service provider will not replace the hardware. Like you have used that particular blade server for say so many months. Now suddenly you don't have a requirement, so you have vacated that. You don't take any more the services of that cloud service provider. So now the same blade server will be allocated to some other company, and if that company is not very clean, then they may recover the data from that server. So to avoid that scenario, to avoid that situation, what will you do? You will overwrite that data. You will encrypt that data, right? You will encrypt that data, and the key will be shredded.
Okay.
So once you have encrypted the data and the key does not exist, it has been shredded. That means that data inside that server, whatever is remained in that server, even if it is recovered, it is useless. It is encrypted. So that is what is overwriting by crypto shedding. Covers up old data with information or crypt text. Degaussing and wiping, we are already aware that what it is, and physical destruction is definitely the thing. Scoping is setting the boundaries. Scoping can include in focusing on controls applicable to a specific data being processed, such as deploying a database activity monitor system, and removing the IPs. Tailoring is refers to customizing a set of security controls to match the organizational charter or mission regarding data or system requirements. Data scoping versus data tailoring. Data scoping describes the contextual boundary, whereas tailoring is fine-tuning the controls to address the specific operational environment. The fundamental difference between scoping and tailoring. Digital rights management or information rights management is a technical control that protects the licensed digital intellectual property right. DRM protects copyright digital music files, apps, software, programs, film, TV shows, games. What is the duration of copyright?
Copyright is for the life of the actor or the inventor plus 70 years.
Absolutely. Security managers should have one or two perspective when for DRM and IRF. They work for an organization that reduces various forms of content that must be protected from privacy, copyright infringement, and ransomware. They must have visibility into end user violation, acceptable use policies, and unauthorized use of unauthorized intent. Customer advocacy groups state that DRM initiatives deny fair digital media access. However, DRM continues to be a practical way to manage digital privacy, avoid piracy, and ensure fair compensation to intellectual property owners. Software solutions, some of the features. Data loss prevention, DLP. It's a collection of hardware and software tools and programs that help safeguard the sensitive data like intellectual property, PHI, health information, and personally identified information. The sensitive data is not leaked, lost, tenanted, stolen, or read by unauthorized user. DLPs are generally considered a program initiative and not simply a product. It, it offers three forms of protection: network, endpoint, and cloud. So, what all data can get leaked? Trade secret, account number, social security number, IPR, PHI, PII, and it can leak when it is stored on network or shared drives, copied to external removable media, transmitted electronically to an outsider who is a competitor, regulator, unauthorized internal user or press or media. So, if that so happens, company will be defamed, There will be monetary expenses for each record loss. There will be legal liabilities, loss of asset, breach of customer trust, closure of the business. The common DLP solutions are next generation endpoint protection solutions, database activity monitors, integrated engines, cloud access security brokers, SIEM and SOAR solutions. It is also called a cloud services broker or cloud access gateway. Secure access security broker. One of the first to offer a product marketed is a CASB was Sky High Networks, acquired by McAfee in Jan 2000, and be API based, proxy based. Visibility, compliance, data security, threat protection. Security design, secure design principle and models based as far as the data is concerned. Principle like least privilege, defense in depth, secure defaults, fail securely, segregation of duties, and keep it simple. Explore privacy by design and default and shared responsibility model. Know about threat modeling, compare zero trust to zero to trust but verify model, and learn about secure access, service edge, survey fundamental concept of security models. We know what is the least privilege. Need to know or staying within one's pay grade. Generally, technically implemented by controls like DAC, MAC, RBAC, ABAC. Enforcing least privilege. Define, discover, manage, and protect, monitor. Detect abnormal users, respond to incidents, review, and audit. So defense in depth, we discuss in detail. It's also called as layered defense. It can be applied to physical security or technical controls. To physical, it should be systematically planned and designed with an outward in or inward out approach. It can be a single appliance with multiple integrated engines. Defense in depth is common element for supply chain risk management. So it could be planned from in to out or out to in. So you have a mission critical systems and it needs to be protected. So you can start with parameter security, then message security, network security, endpoint security, application security, data security, or you can start from data security up the ladder. So at the network end, the multiple solutions which can be implemented to implement defense in depth. At the perimeter side, you can have a perimeter firewall, IDS, IPS, DMZ, honeypot, zero trust, DLP. At the network side, you can have patching, IDS, IPS, VoIP protection, data center firewall, web proxy, wireless security, DLP. At the endpoint side, you can have antivirus, anti-malware, next generation patch management, DLP, endpoint security, host IPS, IDS, desktop firewall. At the applications for towards application security, these are the certain things which you can do. And finally, for the data security, you can have these all technical controls you can implement and ensure the defense in depth for mission critical systems. Again, selection of control will be based on how much value you are giving back to the organization. At the policy end, you can do threat modeling, you can do penetration testing, VA, IT security governance, security awareness, security architecture and design, continuous monitoring. At the operations end, you can make a SOC and a NOC monitoring mandatory. You can implement a SIM. You can have a good incident reporting detection. You can have a dashboard. You can have continuous monitoring and assessment. Secure defaults. When it fails, it should fail securely, right? So a firewall secure default should be deny unless explicitly authorized, right? Unless you authorize it explicitly, deny all. That could be a best secure default for a firewall. Fail securely is a principle that contends that when a system or a server fails, it should have the minimum impact possible on the system security or functionality. A fail secure system reacts in such a way that access or data in transit is denied in case of a failure. For instance, a fail secure door lock will stay locked in a access control system if power is lost or an internal battery dies. According to OS, security mechanism should be designed so that a failure will allow the same execution path as disallowing the operation. For instance, security methods such as is authorized, is authenticated and violated should all return false if there is an exception when progress. If security controls can trigger exceptions, they must be exact about what that condition really means. Segregation of duties, separation of duties. For example, a separate backup operator group from a data restoration group. It involves a dual operator principle where two or more subjects are needed to modify or approve. For example, two signatures or two cryptographic keys are required for a certain action. Rotation of duty is also a related principle, for example, mandatory time off or forced vacation. More examples of separation of duties. So we know that we have to keep it simple and small. Privacy by design and default. Let's take a 5 minutes off.
Okay. All right, I'm back.
Right, sir. So we've done it in the domain 3 as well, privacy by design.
You said we start in domain 3? We have
No,
finished
no,
domain 3.
no. We did domain 3. I'm saying the same thing we have already done in domain 3 also. That is privacy by design. When we
Oh, okay.
discuss,
Okay.
that when we discuss the design should be integrated into the very initial stage itself, right? So from the asset or data perspective also, the same fundamentals apply, right? It means that the privacy is already integrated into the technology, IT system, services, and products to ensure data protection. Basically, the entire engineering process is conducted with privacy in mind, while safeguarding personal data becomes an important. It becomes as important than any other functionality. The function of privacy by design rests on seven core principles, providing the guiding framework for integrating privacy into the business's daily operation. Proactive and not reactive. It should be proactive, preventive and not counteractive. Privacy as a default setting. When we say privacy as a default setting, we need to know exactly the purpose specification, use, disclosure, and retention limitations, and data minimalization is most important. Do not gather data which is not required for your immediate consumption. Minimize the collection of data and identifiably and linkably for personal data. fourth, fifth, sixth principles are embedded into all software design life cycles, end-to-end security with full data lifetime protection and comprehensive visibility and transparency. Shared responsibility model, mostly the cloud model. So the cloud itself must be maybe a threat. We are thinking of protecting our own assets and our security, but eventually cloud can itself be a threat. So what are their security policies and how are they, although it is going to be at a much better this thing because they are the experts in their field, but still it is better to review that. So we've done that in the previous presentation, infrastructure as a service example, the shared responsibility, what is the customer responsibility and what is the CSP's responsibility. So from Microsoft Azure side, these are the this is a chart where who is responsible for what is defined over here. Generally, under any model, the customer is definitely responsible for safeguarding the information and data, devices, accounts, and identities. So data-centric threat modeling needs to be undertaken. There are several types of threat modeling. For example, system threat modeling is threat modeling performed for operational systems to improve their overall security. Application threat modeling was covered in earlier in threat modeling, SCRM, security awareness. Data-centric system threat modeling is focused on defining specific types of data within a system, for example, file, object, or a block. Simply following generic best practices for security is inadequate for protecting critical high value data. While putting a framework and putting it in using it as a baseline is always good, but you will definitely have to tailor it for your requirements because that is not sufficient for critical and high value data. SP 800 144 Guide to Data Centric System Threat Modeling says that the publication provides information on the basics of data centric system threat modeling so that the organization can successfully use it as a part of risk management process. The general methodology provided by the publication is not intended to replace the existing methodologies but rather to define fundamental principles that should be part of any sound data centric system threat modeling methodology. So data centric threat modeling will identify, understand, control, protect and audit. Not really important to remember the steps, but yes, for the sake of understanding, identify what kind of data you have, understand the source of regulated and sensitive data, how they are used and how they are shared, check the controls, establishing policies and controls and governance models with audits, protect, implementing the correct level of data protection, and audit, reporting and auditing to prove how data is used, how who used it, and for what purpose. Again, zero trust here also. Basically, NIST SP 800 207 offers the following zero trust and zero trust architecture operative definition. Zero trust provides a collection of concepts and ideas designed to minimize uncertainty in enforcing accurate, least privilege per request access decisions in information systems and services in the face of network review as compromised. The Zero Trust architecture is an enterprise's cybersecurity plan that uses zero trust concepts and encompasses component relationships, workflow planning, and access policies. Therefore, a zero trust enterprise is the network infrastructure, physical and virtual, and operational policies that are in place for an enterprise as a product of zero trust plan, zero trust action plan. So, pillars of zero trust security are identity, identity, device, network, application, and workloads and data. 7 tenants of zero trust. All data and sources and computing services are considered resource. All communication is secured regardless of network location. Access to individual enterprise resource is granted on per session basis. Access to resource is determined by a dynamic policy. The enterprise monitors and measures the integrity and security posture of all owned and associated assets. All resource authentication and authorizations are dynamic and strictly enforced before access is allowed. The enterprise collects much as much information as possible about the current state of assets, network infrastructure, and communications, and use it to improve its security posture. SASE Secure Access Service Edge, a rapid increase of teleworkers, outsourcing, cloud computing, and the increasing complexity of cyber threats have driven many organizations to reassess their approach to security. Secure Access Service Edge is an excellent approach that provides a unified network and security framework by integrating software defined WAN or MAN and the cloud native security features such as secure web gateways, web application firewalls, cloud access security brokers, firewall as a service, and zero trust initiative. These solutions help modern organizations implement scalable, agile, and secure network access solutions. Access control models are used to determine which subject can access resource objects. They are typically implemented by enforcing integrity, confidentiality, origin authentication, and non-retribution controls. The model designer recommends how a model will be used and integrated into specific designs. It may be done by an individual or committee. Security is best enforced with a multi-level or hierarchical security system. These are some access control models: common, discretionary, mandatory, role based, rule attribute based. Take a moment to go through this. It's important. Many questions may come from in the exam, so just go through the description of this. Fundamental concepts for mandatory access control models: strictly non-discretionary. Sensitivity labels: appropriate for extremely secure systems such as multi-level secure military applications. Main advantage is that access based on need to know, it is strictly adhered to and scope creep is minimized. What is scope creep and privilege creep? What is scope creep and privilege creep? Must know the difference between the two. Are you there with me?
Yes, I'm here.
Yeah. So I was asking the what is scope creep and what is privilege creep.
What is okay, scope creep. Um, scope scope creep. It's a kind of, if somebody get access and elevate that person's access to a privileged user, and then increases or extend to where that person is not supposed to be.
Yeah. So suppose there was a scope and that keeps on changing. The requirements keep on changing. It keeps on expanding basically. So
Okay.
when the scope is not defined, uh, uh, for example, for an audit work, if the scope is not defined, it keeps on changing every day. Then the end result cannot be achieved, right? So, for example, when you are developing a mobile banking app, initially the project scope is basic account review or and transfer feature. Halfway through, the client says, let's also add cryptocurrency trading, AI chat support, and voice authentication. So he's changing the customer, the client, or the environment is changing the scope itself. So that particular problem is scope creep.
Okay.
And a
Okay.
privilege creep is a thing when an employee starts, for example, an employee starts his career in marketing, and he
Right.
gets access to marketing data. Later on, he moves to sales. Then he gets access to sales CRM data, but still keeps the marketing access. So that is a privilege creep. So he has changed the role, but he's a privileged user in both the domains, whereas it should have been revoked. So when that doesn't happen, then the role change happens, and they still have access to both the data of both the roles. That is called a privilege creep. Okay.
Okay. So
Yeah.
how is that privilege creep different from segregation of duties?
Yeah. So if there is a proper segregation of duties, then privilege creep will never happen.
Okay. Okay. Okay.
Yeah, the failure of segregation of duties have will lead to scope creep.
Privilege creep. Okay.
So fundamental concepts of mandatory access control models are all Mac systems involved. From the Bella-Padula model of confidentiality, we have covered it in much detail in the previous domain. No, what was the two lines? No dash up and no dash down. For Bella-Padula model of confidentiality, I had shown you a diagram of a bell. On the left side, it was saying no dash up, and on the right side, it was showing with a downward arrow, no dash down. You remember?
Yes. Yes. So that was no read up and no write down for
Excellent,
Bella.
excellent, excellent, excellent. You have a good memory, I must say. Sitting for such a long and and still remembering
Yeah.
for the first time itself, so it's really commendable. So no read up and no write down. So that's the basis of all confidentiality model which have evolved. And Belletta-Padula model of confidentiality is directly associated. It's a confidentiality model and directly associated with a MAC model, mandatory access control model. This was the first mathematical model with a multi-level security policy used to define the concept of a secure state machine and models of outlined rules of access. So it is a confidential model that focuses on ensuring the subjects with different clearances are properly authenticated by having the necessary security clearance, need to know, and formal access approval before accessing an object under different classification levels. The state of a machine is collected by verify collected to verify the security of the system as it defines the behavior of a system as it defines the behavior of a set number of states, the transition between those states, and the subsequent action that can take place. A particular state typically consists of all current permissions and instances of subjects accessing objects. If a subject can access objects only in adherence with the security policy, then the system is considered secure. So there is a simple security rule, there is a star property rule, there is a strong star property rule, and there is a tranquility principle. Very important. This simple security, star property, strong star property, and tranquility principle. 100% there will be a one question in exam from this. In Bellert-Pudov model, the simple security rule says that a subject at a given security level cannot read data that resides at the higher security level. No read up. That is a simple security rule. The star property rule says no write down. Subject at a given security level cannot write information at a lower security level. Strong star property rule says that a subject who has read and write capabilities can only perform those functions at the same security level, nothing higher, nothing lower. And tranquility principle that subjects and objects cannot change their security level once they have been instantiated or created. So these are the four rules based on which a ballot domino works. Then BBA integrity model also we have done in detail in the previous domain, which is an integrity model, and it is no read down and no write up, and it's a data integrity model. It uses lattice of integrity levels, unlike Bellapudula. States that a subject cannot read data from a lower integrity level, and no write up states that a subject cannot write data to an object at a higher integrity level. Invocation property states that the subject cannot invoke call upon a subject at a higher integrity level. Is also an information flow model like Bellapudula, because they are common where they are common concerned about data flow from one level to another. So it's an information flow model using lattice based and integrity, whereas Bellapudula is confidentiality model. Very important to remember. Clark-Swinson integrity model. Again, key things in Clark-Swinson is an integrity model developed after BIBA model, focused on information and data integrity. Objects can be modified by subjects using read-write operations. It has IVPs and integrity verification procedures and CDIs, clinical documentation integrity rules that are usually defined by vendors. To prevent unauthorized user from making any modifications, to ensure that segregation of duties initiative prevents unauthorized users to make improper modifications, to confirm well-formed transactions, to maintain internal and external consistency. Yeah, so that finishes our domain 2, a relatively shorter domain. We have done the basically I've run through two types of slides. This particular was a lengthier portion, which is good to know. But the ones which I had flashed before this, they you must remember each and every concept that I've explained in those slides. As far as
Okay.
domain 3, we have covered it in detail. So yeah. So would you like to do some questions now?
Okay.
Yeah. So let's take a short break. We have finished with the theory part. So I'll flash some questions. Let's see simpler ones. Let's see how. Right. So I'll be back after 5 minutes. Or you
Okay.
want to take a little longer break? Is it a lunchtime for you over there?
Yeah, if I could get a longer break, that would be good.
Longer. Say. You tell me how long you want it.
Okay, let's do 15. We
15.
can start.
Done.
Yeah. Okay, I'm back.
Yeah. So let's go ahead with the quiz. You can tell me the options, so I'll show you the answer.
Okay. So that is C, the mission.
Absolutely. Yeah.
This is D. Ooh, contract. Ah.
The laws of the country normally would be restricted to the geographical boundaries of the country.
So this is D. So this is C. This is B. D. That is B. This is A. That is C. That's B. That's A. Oh,
The option is A only. I think the it's written wrongly.
you said
It's
you think,
it's A. It's A. It's A. You are right.
yeah. So this, I think it should be B.
B.
Yeah, B. A. B. Go B. A. Patent.
Maximum punishment would be for patent violation. When you compare with the copyright and patent, the patent has a higher weightage.
Oh, okay. Patent is forever. Okay.
Patent is not forever; it is for I think 20 years, right? But
20
but,
years.
but yeah, but if there is a infringement into the patent, then the punitive action is very strong. So it is the
Okay.
strongest protection.
Okay. So B. D. D. B. A. Oh wow.
All are stakeholders, but who among the following must assess the security department? So your operations team, vendors and consultants will not be assisting. They are the stakeholders, but they are not going to assess. The internal and external auditors will, right?
Okay. C. D. D. A. A. B. C.
Rest all are the major changes of personnel, but only D is where one person is changing. So, although he's a key personnel, he's a coordinator, but still the plans will remain in date. They will not go. They will not expire.
Okay.
Okay. So yeah, we'll finish with domain one sample questions.
Oh, okay. B. So let's go back to the previous question. So which of the following choices is not element of government military classification?
Yeah, B is right. That's wrong. C is wrong. B is right.
Right.
Yeah, the explanation says B, but by mistake it is written C over here.
Okay. Yeah. C. D. So A.
Degaussing is for magnetic media. Whereas CDR would be is a optical media, so degaussing will not work over there.
Okay. C. D. Oh. A. Intellectual property rights. Huh.
Yeah, it is wrong. It will be A only. You're
Yeah.
right. A is right.
Yeah. Okay. C.
Close.
Yeah. C.
Yeah. Yeah. So let's do domain three next time. So shall we finish the session today?
Okay. What do we have for today?
Yeah, this only. Domain two and domain three was on the agenda. So
Okay.
about I think 30 minutes are left. So we will make it up sometime later. We were starting
Okay.
something. fresh 30 minutes are not enough.
Okay, yeah. So let's start fresh tomorrow.
Yeah.
Okay.
So we'll start the same time as of today. It's better.
Yes. Yes.
Yeah. So see you then.
All right. See you. Bye.
Bye bye.